Good morning, eminent dignitaries, esteemed guests, and participants. Welcome to this enlightening G20 conclave on renewable energy, advancing skills and entrepreneurship in the PV system circular economy. It is my privilege to extend a warm invitation to a distinguished group of individuals to grace the stage for the ceremonial lighting of the lamp. May I now request the esteemed guest, Professor Ashutosh Sharma, Professor K.K. Pant, Dr. Kinshuk Banerjee, Dr. Vaikje Park, Dr. Binisha, Dr. Arpit Sharma, Ms. Priya Yadav, Professor Lakshmidhar Behra, Director, IIT Mandi, to kindly join us on stage to participate in the auspicious lighting of the lamp, accompanied by a soulful recitation of hymns from the Bhagavad Gita.
Om Namo Bhagavate Vasudevaya. Shri Bhagavan Vacha Urdhvamulamadash-shakham Ashwatham Prahuravyayam Chandam Shriyasya Parnani Yastam Veda Saveda Ved Adhashchodhvam Prasrutastasya Shakha Guna Pravriddha Vishaya Pravala Adhasya Mulani Anusantatani Karmanubandhini Manushya Loke Narupamasyeha tatopalabhyate Nanto na chadir na cha sampratishta Ashvattamenam suvirudhamulam Asanga shastrena dridhena chitva Tatah padam tat parimargitavyam Yasmin gatana nivartanti bhuyaha Tameva chadyam purusham prapadhye Yataha pravritti prasrita purani Hare Krishna, Krishna Krishna, Hare Hare, Hare Rama, Rama Rama, Hare Hare.
Thank you, everyone. I request all the dignitaries to be seated and request our respected Director, Sir, to welcome the audience with his kind address.
A warm welcome to all our esteemed guests, all the faculty members, students who have gathered for our last theme of G20 S20, renewable energy. So I'm very happy that we have with us Professor Ashutosh Sharma from IIT Kanpur, Professor K.K. Pant, Director, IIT Roorkee, Dr. Kinshuk Banerjee from Hitachi. We have Dr. Park from Korea. We have Dr. Binisha and many others. In fact, 3-4 days back we had a flash flood, and that was popularized by the news media so much that for the last day most of our invited guests, they withdrew. But somehow Dr. Kinshuk Banerjee, Professor Pant, they dared to venture to this part of the world, and I'm really grateful to them. And I hope that we will end this conclave G20 S20 with a very pleasant note, with a proper deliberation on renewable energy. And IIT Mandi is specifically committed to green energy, and that includes hydrogen, biofuel, of course solar and other forms of renewable energy, particularly green. That would be more interesting to us from our own perspective of sustainable development. So I look forward to the deliberation, and I again extend my warm greetings to all of you. And it has been a long journey from 21st June to 30th June. So and so I really congratulate the sustained energy that organizers put forth, those who are researchers sitting along with the session, going through the deliberation, and let's have a grand finale to that spirit of committing to academic excellence. Thank you.
Thank you, sir, for your kind welcome address. I would request you to please take your seat. It is with great pleasure and honor that we welcome to the stage our esteemed guest, Professor Ashutosh Sharma, S20 Chair and former DST Secretary. Professor Ashutosh Sharma is a visionary academician who has made exceptional interdisciplinary contribution in nanoscience and nanotechnology fields, and currently serving as chair of S20 and president of INSA. From 2015 to 2021, he served as the Secretary, Department of Science and Technology, Government of India. He is also the Institute Chair Professor and founding coordinator of DST Thematic Unit of Excellence on Soft Nanofabrication and Chairman of Center of Environmental Science and Engineering at IIT Kanpur since 2006. He is a recipient of the prestigious Shanti Swarup Bhatnagar Award in Engineering Sciences for his original pioneering contribution to the understanding of the behavior of thin films and other highly confined nanoscale systems. He was also selected as the president of Indian National Science Academy in 2022. Today, we are privileged to have Professor Ashutosh Sharma to grace this event as a distinguished speaker on the topic of brief history of future.
काम कर रहा है? Yeah, this is, okay, forward. Good morning. It's especially challenging to have the first lecture, but also there's some advantages. I mean, there are fewer people, but people are awake, more or less. So, of course, it depends on the quality of breakfast also. I have had a hearty breakfast, so I'm all ready, and I'm really thankful. In fact, all of us are very thankful for the way this S20, G20 has been organized. I think it has been the best. I have seen maybe 20 of these, maybe not personally, but I know that they happen in different places. But none of them was as extended, as detailed, as in-depth, and as extended as this one going on from 21st. And it started with very auspicious note of Yoga Day, and that was especially heartening that we are able to bring in both the traditional wisdom, so to say, and the cutting edge of science, both of them coming together in a seamless way, and the whole team here, together of course with Professor Lakshmidhar Behra, Director, as well as several deans, and that of course have been around, Professor Satinder Kumar Sharma a lot. So I know his contribution and all the whole team that has worked together on this very important event. My only regret about the event is I missed out on Hema Malini's day, but of course it turns out she didn't turn up. So I think this is perfectly fine. I'm okay, right? I was happy, so to say, that I didn't miss anything. Okay, it's wonderful. I mean, the speakers and the themes, everything which is organized here. Truly, my congratulations on a job well done to IIT Mandi and the management of IIT Mandi. Okay, what is this talk about? So I was thinking yesterday they said it's about energy, and so I was asking some people if they can loan me their PPT on energy, but it seems it was too late, so I put together something yesterday night. So while it is not totally focused on energy, it is more about a more broad brush picture of science, of scientists, of the culture of science, and about and also about energy and sustainability. Okay, so all of these things put together, because indeed they go together, they stand together or they fall together, and we need to make sure that everything is standing together. Energy alone, wouldn't do anything. I mean, you can't really put it in there and use it in a meaningful way unless all the enabling factors were also in place totally. So this talk, as I said, is there is some energy. Of course, one can give a in-depth talk about, let's say, my group. It works in battery or electrochemical systems. But I mean, there are dime a dozen papers in all of that. Anyway, any of you who work in the area can do a better job of presenting that than me. So we will not worry about that. There are specialized conferences for all of that purpose, whether it's hydrogen, the electrochemical energy storage, or other energy storage aspects, indeed. So here it is. It's about science and technology and its directions and determinants, a broad-based picture. It's more like when you paint a painting, it could be impressionist, or it could be expressionist, or it could be cubist, or what have you. So impressionist paintings are those that are broad, dots, something, but you see it from a distance, then you see some meaning that emerges out of it. So, okay, let's look at actually where we are as a nation. Oh, I went in there. Okay, why is it going back? Now we are going in the right direction. Okay, I skipped too many. Okay, so what do you mean by short history of future? One aspect looking at it is the future, the past determines the future. So when we are looking at present, the whole of history is actually embedded in us, and it gives a very good idea about where we are, who we are, where we're going to go, and how we are going to go there. So this is about the history of future, which is the present actually. Okay, we know that what are the challenges of the future. I talked about them yesterday a little bit. Is the rise of intelligent machines, is sustainable development, is from moving from invention to innovation, is about being inclusive and respecting diversity. So let me just very quickly clarify the difference between invention and innovation. In fact, 80% of the scientists don't know the difference either. In fact, there was a committee of CSIR that was going to make a Bhatnagar Award for innovation. The committee met 3 times and could not decide on how they're going to judge innovation, or indeed what innovation means. So if you talk to 10 different people, they would say innovation, very innovative thought or something. They'll say very creative, very something new. It has nothing to do with creative thought. Let me put that to the rest right away. So let me define the difference between invention and innovation, and what indeed is the challenge in moving from invention to innovation. In fact, India is pretty good at invention ecosystem, but not equally good at innovation ecosystem. And so invention, basically I think of it as a black box in which money comes in and knowledge flows out. Which is what the universities, IITs, everybody does. So we need support, we need money in order to produce knowledge, in order to transmit knowledge. Innovation is 180 degree out of phase with invention. It's another black box. If you don't like black color, okay, red box, whatever box it is. But basically the input to that box is knowledge, and money flows out. So 180 degree opposite of invention. So therefore the processes of invention and innovation are mathematically orthogonal to each other. People make the mistake of thinking the same way about innovation, startups, as they think about a university or producing great ideas and so on. Most startups would fail that start with a great idea. Okay, and that's the reality of what you call the marketplace, is the consumption of knowledge. So while creation of knowledge is one aspect, consumption of knowledge is another aspect, and they are not necessarily equal to each other. Innovative thought, therefore, would mean the thought, the idea which has a potential to generate economic impact. Right? It may not be a great like theory of relativity or something, but it basically has in it the seed of being translated into economic gain. Okay, so we'll look at quickly about the strengths and weaknesses of S&T in India, what makes S&T and innovation work or not work, what is the mind, the processes of mind which are required actually to close the circle of knowledge, which means the circle of knowledge I define as producing knowledge and consuming knowledge and therefore closing the circle. It goes from one pole of knowledge to economy on the other pole, and it recycles between the two. And so when we talk about sustainability in a society, sustainability of knowledge is so important. Because if we converted all our money into knowledge, that's wonderful, okay, but then you are sitting on pile of knowledge and no money at all to support further knowledge. And so therefore it is the symphony between invention and innovation which makes for a healthy, balanced society. Okay. And then finally I would like to conclude, I'd like to point out that I'd often thought about that the world, a century away world of, for example, Acharya J.C. Bose and C.V. Raman, they were not so different from the world in which we live today for science. And so often people ask, hey, what is it I need to do do good science, right? And they keep asking, why these people were such great people, they got Nobel Prize and stuff, how come I can't get it, right? So some of the answers to those questions we will find by examining the minds of J.C. Bose and Raman. And in fact, indeed concluding that their times were not, okay, infrastructure is different, but the times and the processes of doing science back then, the challenges and opportunities were very similar to where we are today. So there are lessons in it to be learned. Let me, go through this very quickly. What makes S&T work or not? The first is the invention or the knowledge creation ecosystem. And we are sitting right here at one of the high temples of that process, if you would, all the IITs, the central universities, ISERs and so on, which is the invention ecosystem. And indeed, our invention ecosystem is very strong. I mean, great scientists, minds, everybody, they can produce good knowledge if they know the relevance and direction which may come from outside. The innovation ecosystem, I pointed out that, which consumes knowledge and produce new opportunities. That, I'm afraid, is not so empowered in the country. So when you talk about where is the weakness in our science, it is not so much an invention ecosystem as its connect and interface with the innovation ecosystem. And the innovation ecosystem itself, historically, we know how it worked. The marketplace, it said it's not so important about what you know, but who you know. So culturally speaking, that it was molded in a different way. So therefore, if you're not in a knowledge economy, you don't care about knowledge because that's not what makes you the money. So as you transit into more and more of knowledge economy, that connect with the invention ecosystem becomes critical. I mean, some company like Google spends more for R&D than NSF, which is the all of funding arm of the government of US. So indeed, if we were to have companies like that, which ride only on knowledge, and then these two things come into play and they couple with each other automatically, is because the metaphor that I was using, Lakshmi and Saraswati chasing each other for their own good, and not be partitioned very strictly. But if you know the personality of Lakshmi and Saraswati, not that I claim to know it very well, but it's likely that Saraswati will not be chasing Lakshmi because it's contented in its own playing veena, right? Whereas the thing is about the pull and push of knowledge. And it's like hydrogen bond, you can give electron, but you can't accept electron, there is no bond. And so invention and innovation ecosystem together make the bond possible, right? Okay, so of course policies, rules, laws, structure, processes, vision, very important for science to work. I gave an example yesterday's session about a single policy that can make science work for us and can have an impact of tens of lakhs of crores on economy with a single line of policy. I'll probably not have time to repeat it, but it's such a compelling story to understand how without policy our science will not work for us. Connects between different things, education, skill industry, all of that. I will now actually, in this particular talk, I would emphasize more the cultural and behavioral aspects. Most important, nobody talks about them. All the conferences, 372 that I have been to in my life, and not one of them actually talked about what makes good science possible. It is not my training, it's not my PhD, by the way. Everybody has it. Everybody, now we produce 25,000 science and engineering PhDs in the country every year, right? So there is no lack of training, there is no lack of nothing. So what is it that perhaps we have to focus on is the cultural and behavioral aspects. I get more and more convinced that this is where our weakness actually resides. We're getting there. So what's the good news? India is number 3 in number of scientific publications. It has risen through the ranks very, very quickly. Just 10 years ago, it was number 8 or so. We have deep strengths in R&D and the institutions of R&D, such as this. Demography is on our side. The median age of India is below 30. You can imagine so many young people. You see there? So many sitting there. Young people ready to roll up their sleeves, do rock and roll and say, hey, we'll have a startup, we would do all this stuff, great stuff. Take risk. That energetic feeling is there in the nation. You can see it in the malls. I go there, if I go to a mall, I'm the oldest guy, there's nobody there, everybody below 30. Okay, and policies happening, huge diversified markets, great demand, so everything is good. What about the weak points? Our quality is a little bit below quantity, that we know. Relevance and direction of research that we pursue is not so good because our interface with the outside world is weak. The pull of knowledge comes only from outside. You can only go that far with pushing knowledge, because the point is, everybody does what they are comfortable doing. After doing it, then they look for the takers for that knowledge. Is never going to happen. There is an old story about Mullah Nasruddin. He's a wise man of the East. So Mullah Nasruddin lost his bunch of keys somewhere and is searching for it 5 hours. Then his friend came and joined him in the search. Then after 2 more hours, he said, Mullah, where did you lose these keys? He said, why? I lost them there. He said, why are you searching here? He said, because there is more light here. So, we all do what we can, what is convenient for us to do, rather than what needs to be done. And so what needs to be done, that wisdom comes from outside us, not from my lab. And so because the interface is very poor, so we don't get there. And then of course, one has to move from being tool-centric to problem-centric, which means I may know few tools of trade based on who I am, what training I received. Then I try to go around matching those tools to the problem. That's again a very inefficient approach to solving problems. First one is to define the problem, develop all the tools which are needed and the team which is needed to solve that problem. Leadership, okay, so we forget about that. So this is about, I must advertise being involved in S20. So S20, the overarching theme is disruptive science for sustainable development, and I talked a little bit about it yesterday, which is to say, look, why disruptive science? Because the science as usual, the business as usual will not solve our problems of sustainability. That's fairly clear. So therefore, you have to think different. The mind has to become different. The cultural processes have to become different. And all of this has to be a little bit disruptive, which means you accept change. And in fact, that we welcome, we actually engineer that change, so to say. And so here's the problem of sustainability, climate, living in a complex world. This is actually the tax on development, right? The climate change is the tax we must pay if we make money. Now, oftentimes I thought about it, the sustainable development is an oxymoron, because our definition of development runs through the Chicago School of Economics, turn of the century, which says more you consume, happier you are, and richer you are, and more developed you are. By the way, development has many senses. Unfortunately, we have come to identify with one of those which is purely in terms of consumption and extrapolate it to all other aspects of development. I mean, you can talk about cultural development, you can talk about spiritual development, you can talk about family development, social development, and so on. Unfortunately, we have clubbed all of them together, and you say, hey, developing country, it means they're a little bit semi-barbarian, right? But that's not true. In fact, sometimes it could be inversely correlated, but that's a separate problem. So here are big challenges of sustainable development, and we all know about it. No matter what kind of engineer or scientist I am, I must know where my work belongs, where does it fall in one of the 17 and the sub-themes. If I have not looked at it, then I have not understood what I'm doing, because every science will actually plug into this. Every kind of engineering for the years, decades, centuries and millennia to come would continue to plug into one of these compartments. And so we should identify what those compartments are, so I have a bigger picture of what I do in life and research. Okay, now I want, of course, that there are so many science and technology details in each of these goals and sub-goals. Let me skip all of that. And let me just point out one aspect which is so important, and as engineers, as scientists, we totally ignore it. And that aspect is this. Which says, the guy said, I used to think the top environmental problems were biodiversity loss, ecosystem collapse, and climate change. I thought that 30 years of good science, we could address these problems. But I was wrong. The top problems are selfishness, greed, and apathy. See, at least one person agrees with me, but she's not a scientist, by the way. so I'll come to that in a moment. Huh? So he's saying, and deal with those, we need a spiritual and cultural transformation, and we scientists don't know how to do that. What he's saying about scientists is true for every section of society. So it's nothing special about scientists. We are as selfish and greedy as everybody else, the businessman and everybody else. So the point is, where would this transformation come from? Because an industry is not going to produce it. A scientist, an institution is not going to produce it. President of country XYZ is not going to produce it. Nobody is in control. Which means it's a ship on auto. कभी हम यहाँ बोलते हैं ना कि वो भगवान भरोसे चलता है, वैसे ही चलतेगा. So now you see, this is a very complex problem, and it's got dimensions which are outside of science and technology, while you need technology for more efficient consumption. Right? But the consumption itself will keep on increasing. And of course, for developing countries like India, you need that. This is part of climate justice, if you would. Right? But there's again another complex policy matter that we would not delve into here. But needless to say that, okay, what is the meaning of developing a country where every family may have 3 cars on average, is to add another car. Okay, so that in that context, the meaning of development is that. In our context, the meaning of development is a little bit different. It may be about roti, kapda, and makan, satisfying those needs. Okay, so let's say these are overarching challenges: living with intelligent machines that impact every aspect of our life, living with climate change, living with sustainable development, living with the rise of antimicrobial resistance, negotiating globalization and diversity and inclusion. All of these are overarching challenges of society. And of course, science technology is greatly embedded in this larger picture. So what kind of mind is required actually to deal with all of this? This is what I call preparing the ground, fertilizing it, putting some irrigation, stuff in there. Okay? So what kind of shifts that are happening and would happen in a very strong way is about creativity. And also remember, the rise of intelligent machines means that everything that we thought humans are good at doing and are exclusively humans are good at doing, all of that's going to go away, including the cognitive and the creative processes, not just manual processes. We already know ChatGPT. Some people laugh at it. They say, hey, it doesn't know anything. It's giving me wrong something. Hey, this is only the beginning. Just wait 5 years. And within 10 years, no human can compete with the cognitive, creative processes of similar kind of engines. You can write, your own novel in whatever style you want, Hemingway to Shakespeare, specify the plot and characters and specify the style, it's going to write it for you, right? So the question that you would come to ask is, what is exclusive about humans? How do you differentiate yourself from intelligent machine? That's a very complex question, but we would be considering it, we continue to consider it in all future to come. Only the beginning now. And so what is creativity? Creativity is connecting the dots of knowledge which have not been connected before, and therefore bringing in new value, saying archaeology connected with chemistry and so on, as an example, right? And which is, I keep telling people that I rarely talk to people who have the same background as me, because the learning process is superficial and very slow. Wherein if I go talk to somebody who is totally different than me, then the learning process is novel and it is fast. Right? So this is about connecting the dots, creativity, even common sense, if you would, scientific common sense. Often machines lack it right now. I don't know how it's going to be in 50 years from now, but it's something that we can compete because we can extrapolate from many different ideas, bring them together, the synthesis rather than analysis. Even though our education is totally analysis based. What does it mean? It goes from chapter to chapter, it goes from course to course, exam to exam, degree to degree, but it's all divided, totally chopped up in hundreds of pieces. There's no synthesis. And so basically what we need is synthesis. And we talk about all interdisciplinary, multidisciplinary, transdisciplinary, out of disciplinary, whatever you call it. Right? This is actually a huge misunderstanding. What happened is this. When we started making colleges and the knowledge, we fragmented knowledge into 1,000 different pieces. It's like Humpty Dumpty. It's very easy to break it. But to put it back together is anti-entropic, and it will never going to happen. Okay, and so putting together pieces of fragments of knowledge is such a tedious job, and which is why we never succeed. That's why, you see, interdisciplinary, multidisciplinary is the base. It's not a top. Now what we think is we got so many disciplines, we'll put on top of this another layer which is called interdisciplinary. Interdisciplinary is the base. It is not the top. Right? And so we have often forgotten this. I'm very happy to see in Iit Mandi that there are so many interdisciplinary centers and that they can hire their own faculty. That's most critical. Because I talk to many directors, they say, they're all talking great things about interdisciplinary and so on. But I say, can you hire this guy who's got B.Tech in A, M.Tech in B, PhD in C? They say, no, because only departments can hire. And none of them will hire this poor fellow because he's so good. We only want mediocre people, not good people in this. Right? So this is what happens. Okay, and of course we have that. Let me very quickly go illustrate the meaning of creativity with some examples. What is creativity? Let's look at the case study of rise of atomic force microscopy, scanning, tunneling microscopy, which made nanotechnology possible. Everything, right? So it's very simple. You want to see something very small. Now you can see, when we think about seeing, we think that there should be light, or at least there should be some radiation. Maybe an electron beam, maybe ion beam, something, the radiation that interacts with matter, and then let me see. The smaller the wavelength, the smaller things you can see, right? But if you think about, there is another sense of seeing. How does a blind person see? You take a stick, you walk around, you tap the surface, then convert that pressure map into a visual map. There's another way of seeing which is purely mechanical. Now, if you were to convert that idea on a small scale, then you will have a stick which is a micro stick, it's called cantilever, and then you would tap on the surface while moving in a controlled way, and therefore you get the topography of the surface, which is what AFM basically is. You got a Nobel Prize very quickly. In good old days, you got Nobel Prize when one leg is engraved, but now is an example of, within few years of this, it had a great impact. By the way, it also illustrates the fact that today, Nobel Prizes, a whole lot of them go with very applied science, okay, or even with technology. They are tied with technology or the rise of technology. So, there is greater emphasis on doing things applied, so to say. So this is the story of AFM, little cantilever tapping on the surface, looking at atoms, molecules, and small things. So question is this: in today's world, what I would like to convey is that technology is not the bottleneck. If I have an idea, that's the most important thing. Think about an idea that nobody had before, and it could be because I'm borrowing idea from another area. Right? So for example, this concept of seeing and how I can convert that into a product or a technology. And so it works. Okay. Here, another thing about doing good science is about serendipity. Serendipity is things that happen by chance, right? But nothing happens by chance, or especially taking advantage of chance does not happen by chance. That for sure. So people are prepared to grab that little chance because they are totally focused on what is happening. Now, most of the people are focused at the end of the experiment. They have certain expectation from the end of the experiment, and therefore they miss everything that happens in between. It is so amusing. Oftentimes people, especially doing PhD and postdoc, they would come and say, this experiment failed. And I never understood what it means for an experiment to fail. There is no such thing as a failed experiment. There is such a thing as failed theory. Okay, the experiment is a reality of what happens. And you cannot say that this is all wrong. I mean, you have to find some meaning and interpretation in what happens, even if it is not to your expectation. And so here is a classical example of graphene, which got another Nobel Prize, is a master of material science today. Graphene is a two-dimensional sheet of carbon atoms, right? And so how do you get it? Well, you take a block of graphite, you put a tape on it, the surface, and peel it to expose the new, fresh surface of the material. Except that, of course, this experiment was being done for 100 years by many labs. Essentially, they had interest in cleaning a block of graphite because they want to study graphite. Graphitic block, remove the dirt and stuff from the surface. So you put the tape, you peel it, you throw away the tape and keep the graphitic block. These guys, what they did is they kept the tape and threw away the graphitic block. Right? Now what happens? Because of the very weak cohesion between carbon layers of carbon atoms, when you peel the tape, sometimes you have two-dimensional layer of carbon atoms will stick to the tape, and then if you examine the tape, it becomes clear that this is graphene. So it's a question of, not just, one should not be very narrowly focused day to day for 5 years saying only this is of interest and nothing else is of interest. So if you discard everything else, then most likely you will never see anything new, because whatever that we are focused on, 1,000 people have already seen it. Okay, here's one example from my own experience lab about nanofabrication. So nanofabrication, some of you know, basically there are two techniques for making something small. One is called top-down, which is using a machine tool, a radiation or something in order to make something small. Or the bottom-up is something what is called self-assembly or self-organization. Lot of atoms or particles coming together spontaneously to make something bigger and useful. And so that, but we are thinking, is there another way to make something small? And so we saw this movie in the 1980s. It's called Honey, I Shrunk the Kids, right? So it gives you the idea, if I make something a little bit bigger and shrink it, I mean, it looks like laughable idea, right? But remember, no matter how ridiculous the idea is, you can translate it in reality. And so we started doing that. In fact, it's straightforward and not so difficult. And the thing was that after a month or 2 weeks of work, we could publish in the top journal of material science called Advanced Materials, which is only to prove that people are hungry for ideas. If somebody say, look, I got a lab worth $1 billion, nobody's impressed because there are 1,000 other people who got that $1 billion lab sitting with them. So while having a good lab and infrastructure is necessary in many cases, it's far from sufficient. What is sufficient is to have a good idea and then translate that into action through infrastructure. Infrastructure then give idea. People give ideas. So people have to be empowered culturally with confidence to be able to do that. So here what you do is, well, make an object which is micro scale, let's say lithography, different kind of top-down techniques and so on. Then do molding with a gel. Then dry the gel so it shrinks. And you can repeat the process in order to make a good copy of the big object on a smaller scale. If you do it 4 times, you reduce dimensions by 1 order of magnitude. And this can be done in a high school lab. You can make nano objects in a high school lab without any tools for doing that. It could be a 3-dimensional complex object, which is very hard to make, even with ion beam. Professor Satyendra Kumar is here. He is an expert in nanofabrication. They'll tell you, if you want to make, a small copy of Hema Malini, how are you going to make it? Not possible with ion beam, I'm afraid, but you can do it with this technique. Okay, there we go. Let me give you another one case study from my own lab. This is a problem that we worked on for 25 years, different aspects of it. It's a fascinating story. We all, professors, scientists, we should have one problem that we work on all of our life. in addition to all the other stuff, small things which are going on in our life, but there should be one which is something that gives the purpose, and it's an open problem, and there are many fascinating aspects. This particular problem we were working on is called self-organization of nano objects. So when things are very small, they are unstable, and they want to change their shape spontaneously. If you understand what the mechanisms of these change are, you can actually control and guide them to make things which are useful. For example, this periodic array of polymeric domains, often of micron size, but large area. This could be done without going to details of this, like pointed out, 25 years and 10 PhDs later. Okay, so let me give an overview. So idea is to self-organize polymers of different kinds, maybe periodic structures, quasi-periodic structures. You can make sensors with it, can do polymeric, optoelectronics and so on. Whole lot of things you can do with it. The idea is that without using any machine tool, can you organize, self-organize matter on small scales. And here's an example of that. We were doing that. So here if you look at it, basically this self-organization on small scales produce this array. In one case, this array of polymeric lenses that you see over there. Now interestingly, it turned out that these small lenses, you can do near field optics with them, which means you can see things beyond the diffraction limit. Everybody knows optical microscopy, how does it work? You can see things which are of order lambda by 2, where lambda is the wavelength of radiation that one uses. But in these, the near field optics, that limit is broken. Okay, so when people ask me, hey, how did that happen? I tell them, I am an engineer, I don't know quantum mechanics. Please ask to nano optics guy, okay, to explain you what it means. But anyhow, you put that lens, let's say on Blu-ray or DVD tracks, you can see them when you cannot see them with a 20 lakh optical microscope. So very easy to make this kind of thing. But so we wanted to do, another issue is that when one does something fundamental, basic, exciting, one has to find uses for it. So you go about looking for, hey, I'm going to do all this organization, very good. What is it that I can do with it? So we did a lot of, optoelectronics, can do signal enhancement using this array of lenses. You see, there are also a lot of inspiration from nature. Nature is the best storehouse of technologies and science, because it just had a lot more time than humans to do it right. So if you were to look at the eyes of insects, they are compound eyes. They are made up of an array of lenses, and this is because you can have a detection of rapid motion, which is so important for poor insect to escape from predators, right? So you can make this kind of compound eye or the mass for photolithography and so on. In fact, I got the idea by watching an old movie here. See, so let us very quickly play that if it does, and see where the inspiration comes from for different things. We have lots of new school students who walked in. They would be totally fascinated by this movie. We should take some break in our lives, watch this. We take a little bit of break in life, but you also get some inspiration, as we would see in a moment. Yeah. What is this? Not looking happy at all. But anyhow, you see, here we have a complex object. Name is Madhubala, 3-dimensional. Now, if we wanted to make small copies of that complex object, this way that you take an array of micro lenses, shine the object in it, capture it on a photosensitive material behind it, and there's photolithography basically. So in order to make this array of lenses, you can make use of self-organization in polymers. They want to illustrate. So essentially, a good science process, a good scientist when you're looking at the world, you are looking at possibilities. You're not looking at the world at all. What you are looking at is, hey, what does this clip means for me, for my research, right? And you would immediately find so many different ways of doing that. Okay. Now, since of course this thing is about energy, so let me put my 2 bit about energy. Of course, we all know about hydrogen. We know the challenges of hydrogen, which is going to be green hydrogen, which means you split water using solar energy. You need efficient catalyst to do that and all that. Then of course the next thing is, okay, what about the transport of hydrogen in a secure way? What about the storage of hydrogen? What kind of materials would be needed for that? Then of course transforming back hydrogen into another forms of energy, and also use hydrogen for storing energy, which is a very big thing, because with rise of renewables, you need to have grid balancing. And to be able to do that, you need massive storage. And of course, right now we are doing lithium-ion batteries and what have you. That's childish. I'm not going to survive very long because there's an intermediate age in which mobility is tied to lithium batteries and so on. But that has to go away finally, because that's not a permanent solution. The permanent solution is fusion, and we may get there, we may not get there. Absolutely nobody knows if we'll get there and where, when. So, okay, barring that is hydrogen, clean hydrogen, green hydrogen. And so there are many technical challenges which the whole world is working on it, as well as the energy storage solution. But here what I'm going to talk about is something totally different, okay, which is people don't talk about that. They are like, you see, when you have a whole lot of solar energy, what you do is first you convert it to high voltage AC, and then you feed it into your appliances. But if you have rise of DC based low voltage appliances, it's far more efficient, because you don't do up conversion, down conversion, and all of that. So you generate solar energy at low voltages, and so you can directly use that with DC appliances. You generate DC, right? So eventually it's possible that with greater use of standalone solar energy, there would be a flourishing market for DC appliances, and that saves a lot of energy. There are good studies based on that. Now, if you started efficient water pumps, you see it is also the commercial models that matter. You know how LED actually succeeded in saving a lot of energy? LED bulbs, one day we were using all these tube lights, and the other day we started using LED bulbs, which are far more efficient. It's not about technology alone. The acceptability of LED happened because of a business model, which is called aggregate the demand, and then you pay as you save. Okay, so same kind of business model if you were to put into appliances of different kinds and so on, including, for example, here the example is solar-based energy efficient pumps, and the parenthesis actually shows the potential for energy savings by that particular intervention. Oh, by the way, when talking about efficient solar water pumps, I want to illustrate the fact that every technology, everything that looks very attractive, has both a light and a shadow. In this particular case, it was a big project which was going to be between India and Israel. I had to put my foot down and stop it. Why would you say that that should be so? Here is a very efficient solar pump for irrigating our fields, and it can draw water from very deep, which was not available with the existing pumps. Now, what do you think is the danger? Danger is, well, everybody will do flood irrigation and deplete the water because all free. First of all, your solar energy, 24-hour supply. You can't cut it off, right? And with some backup. And so what is going to happen is that there would be totally unnecessary exploitation of groundwater, because you can go very deep on top of that. So you have to balance every technology, no matter how attractive and bewitching it looks. You have to look at its shadows. You have to look at its unintended effects, if you would. Okay, a whole lot of these things you see are not related to technology, and this is a point that I wanted to bring in, saying that even with the existing technology, you can save a lot of energy. And these are by interventions, for example, new energies, efficient buildings. If everywhere you have regulations regarding how much of land one can use for buildings. You say, look, if your buildings satisfy this code, then you can build a little bit more. So you can incentivize, but without paying money from government coffers. Right? So there are many interesting tricks that people can do, and even can be done on an institutional level for incentivizing, for example, people who perform well, without necessarily giving them more money. This was actually very interesting. The last one you see, actually a study found out that all these bus drivers, truck drivers, or even the car drivers, there's no formal training for efficient driving. The efficient driving can save so much amount of fuel, is unbelievable. I couldn't believe it, the whole study, when I read that. So if we had this mandatory course, you can actually have as much as 10% savings in fuel right away. Whereas if you think about technological fix, you say, hey, to do 10% more efficiency is very hard in the existing engines because they've already achieved their optimal performance levels. Another thing that you look at, you see the freight transport. For example, transport through rail and waterways is far more energy efficient than through roadways, right? We all know that. Great disparity between the two. Why do you think that people are not using railroad for small hauls? I mean, within 300 kilometers and so, it's usually truck that dominates, not the rail, not the waterways. Why? Because the ease of doing business. You always forget anything controlled by government, ease of doing business goes out the window. But you see, people are paying attention to it. You must have door-to-door delivery. Nobody cares that, I first get my stuff to railway station and then it goes to another railway station. It sits there, you get it out and then get it to your home, right, or your factory. That doesn't work. People want door-to-door. So what that means is that you have to have networks, which means the trucking company is working with railways, and you basically book the stuff to the final destination. And those small interventions can save a whole lot of energy because then more efficient modes of transport can come into play. So sustainable mobility, of course, is a big area for emission reduction. One can do efficiency enhancements of powertrains. There are a lot of what we call the technological fixes. The non-powertrain enhancements, which is as simple as aerodynamics. You would recall 10, 15 years ago, the trucks that you looked at, their front side would be flat like this. And that increases the aerodynamic drag a whole lot, which means you are doing a lot of fuel is going out, doing nothing. But if you were to streamline those surfaces, like the wings of an aircraft, then you have less resistance and you are wasting less energy in overcoming the air drag. As in now you see the whole lot of trucks are retrofitted with something which is smooth like this right in front. So that's a piece that one can add. One can do much better, but of course these are not scientifically designed. The greener powertrain technologies and the alternate fuels, of course we all know that finally hydrogen is the savior, if you would. Okay, let me skip this. When you talk about sustainable mobility and circular economy, of course, not just in transport but everywhere else, the mantras are you can either reduce or you can reuse, recycle or regenerate. Everything starts with R. So that's why they are called RRs, RR, triple R, 5 Rs and so on. Or renew or regenerate or recycle or recover and so on. So this particular study was in the context of tires that go, so it save a lot of energy by doing that. And of course that you do the recycling there. For sustainable mobility, and indeed for sustainable many other things, there are 5 business models. So you can have circular supply chain, which means provide renewable energy, for example bio-based, recycle input materials to replace single life cycle inputs. Oh, by the way, when think about recycling, don't always automatically assume that plastic is less eco-friendly than glass. We don't have time to go into it, but one has to do a bit of analysis, deeper analysis and scratching the surface. By the way, don't assume that the plastic clothing, the synthetic clothing is more eco-friendly than cotton. Yet another of those paradoxes. To have produced 1 kg of processed cotton, it takes 9,000 liters of water. In those places where we don't have water, it comes from underground water. The only reason cotton is cheap is because we put no money on water. So because of policies, we say water is free, and even the pump power to get water out is free. So all of this is free, but it is not free. There is a cost in terms of environmental degradation and the use of water. So every time I'm exporting 1 kg of cotton, I'm actually exporting 10,000 liters of water, which is not there. Okay, so just remember these things. So now what happens is we often look in technology in isolation. We look at products in isolation. What one has to pay attention to is 2 aspects. One is called the life cycle analysis, from birth to death and beyond the disposal. And the second aspect is nexus, which means nothing is isolated in this world. No man is an island. That whatever I do here affects everything. And to look at it. Anyway, let me skip that. How much time is there? Over? I have to conclude, yes, indeed. So let me skip all of this. One major idea that I want to leave with. This is something I want to leave with that because this is not something you will find in any literature at all. Okay, this is a lifetime of synthesis, if you would, starting from 1977, when I did Psychology 101. Psychology 101 basically defines life goals as a hierarchy of achievements. And this is called, let's say, Maslow's motivational model. What motivates people in life? So right at the bottom of it, they're called deficiency needs, roti, kapda and makan, needs for safety, for belonging, love and esteem. And then what you may call growth needs, which are needs cognitive, aesthetic, self-actualization, transcendence, what you will call it, right? So now, interesting thing about all of this need model, of course that the bottom needs, which are called deficiency needs, are well addressed by technology. But all the rest of it has no correlation with technology. In fact, it could be inversely correlated. So often people make the mistake of saying that if I added another 0 after I already have 6 zeros in my bank balance, if I added another 2 zeros, I would take care of those needs. Not true at all. No correlation at all. So therefore, it is good to recognize that early on in life that there are certain things you do which comes from external technology, and there are certain things you do that come from internal technology, and there is no conflict between the two. And don't think of this as a conflict between science and spirituality. That would be too immature to think in those terms. But this is a reality, right? Okay. So here, summary. Okay, here. So I talked about the fact that most of our problem, even in science, technology and everything, is cultural and behavioral. And so I would close this session by quoting from what J.C. Bose was saying and what C.V. Raman was saying, as I pointed out that those things are relevant for us today. So it's a brief history of the future, and which is here. So the Acharya J.C. Bose, by the way, a lot of people write Sir J.C. Bose. Please, Sir left in 1947. Okay, I hate it when people call me Sir. And I keep telling them, please don't call me Sir. They say, yes, sir. Okay, but never mind. Okay, that's the reality of life. But I prefer to use the word Acharya rather than the British honorific called Sir. Okay, the best way to predict the future is, right, this guy was until 1937, right? He was influenced by, these guys were actually very much steeped in the tradition. They drew their strength from the tradition. So the character of Karna in Mahabharata, I say, like that of my boyhood's hero Karna, my life has been ever one of combat and must be to the last. It is not for men to complain of circumstances, which is all that we see in today's world, by the way, but to accept, to confront and to dominate them. Okay, let's look at the disruptive and creative elements and unconventional thinking, backed by evidence, of course, not flights of fancy. In those days, something, saying something like this would have been a total revolution. Most of the scientific world will say you are madman. Okay, now I was saying that telltale charts of my Cresco graph are evidence for the most skeptical that plants have a sensitive nervous system and a varied emotional life, love, hate, joy, blah, blah, blah. Countless appropriate responses, stimuli, as universal in plants as in animals. Such a revolutionary thing to say. Most people would be so afraid to say it. They'll say, what would the world think about me? As in one of my conferences, one woman participant, entrepreneur with a startup told me, our major problem is LKK. And I said, I was totally puzzled. I said, what is LKK? They said, log kya kahenge? There we are. So if you log kya kahenge, if you worry about, you're going to do nothing, you're going to do zilch, right? And so this is, confidence. Basically, the cultural element of confidence is so important, but so overlooked in our classes, in our way of doing things and so on. Okay, here we go. Reasoned optimism and justifiable pride. Capacity to endure through infinite transformation must be innate in that mighty civilization which has seen the intellectual culture of the Nile Valley, Assyria, Babylon wax and wane and disappear, which today gazes on the future with the same invincible faith with which it met the past. Okay, so this is the faith, by say reasoned faith in our ability and our ability to build a future for ourselves and indeed for the rest of the generation here. Importance of science communication, very important. It has totally gone in decline. We as scientists never communicate with the public about what is happening. So I have sought permanently to associate the advancement of knowledge with the widest possible civic and public diffusion of it. This without any academic limitation, henceforth, all races and languages, to both men and women alike, for all time coming. Such a revolutionary thing. And in fact, he was doing it. They were running a science magazine, a popular science magazine in Bengali and everything else. Okay, here let's shift gear and come to a more contemporary figure than J.C. Bose, C.V. Raman. It's about taking risk. It's about taking responsibility. I am the master of my failure. If I never fail, how will I ever learn? Moreover, people often believe that successes are their own, but failure belongs somewhere else. They say, for failure, my director is responsible, my PM is responsible, president or somewhere is responsible, right? But when I succeed, everybody is so happy saying it's because of my capability. It happened. So this is cultural, right? And this guy is saying, look, I am the master of my failure, right? And okay, learning from failures. You can't always choose who comes into your life, but you can learn what lesson they teach you. And the sense of science is independent thinking, hard work and not equipment. When I got my Nobel Prize, I spent 200 rupees on my equipment. But I'm not suggesting that all of us get 200 rupees and get Nobel Prize. They're not going to happen. We need good infrastructure and equipment, like I pointed out, is necessary, but not sufficient. Confidence is the key. And I often tell, if I go, especially convocations and stuff, I say, look, the key is to lose energy vampires. Other people suck blood, they suck energy with their negativity and leave you as an empty shell of a zombie. We have, I think, developed an inferiority complex. I think what is needed in India today is the destruction of that defeatist spirit. So, okay, there are many take-home lessons. In fact, this stuff came from one full 1 hour lecture I gave on J.C. Bose on his centenary, right? So, to conclude, basically, what I would like to say is that while we ignore and underestimate the cultural and behavioral aspects of doing good science, those are the key. It's no longer the training, we have the best of institutions. It's no longer the IQ. Everybody is, cracking these great exams that nobody in Harvard can crack and everything. So therefore, what is the key? What is it that we are lacking? We are lacking the behavioral aspects. I know this because I have grown up in an IIT, 30 years I have spent in one campus. And I am so sad to see that there are people sitting in tea club doing gossip for 3 hours every day. You can recognize those elements in every campus. And the great universities of yesteryears have gone down very fast because of petty politics, is because of negativity, is because people have no sense, have lost sense of ethics, right? Okay, so thank you very much. I stop there.
Thank you so much, Professor Ashutosh Sharma, for a thought-provoking talk. Now, I would request Professor Lakshmidhar Behra, Director of IIT Mandi, to please honor our guest, Professor Ashutosh Sharma.
While he is coming up, if there is a question, I can quickly take. Yeah?
I would encourage the audience
questions?
for questions.
Oh, by the way, I already got one of this stuff yesterday. Can you change it with a shirt? My size 42.
Actually, given already, right?
No, don't worry about it.
Not given. Thank you. I have a question.
Yeah.
This self-organization that you did in nanostructure,
Right.
is it that similar self-organization is there when we deal with body and mind,
Of course.
even in a thought.
Yes.
Have you ever thought about this?
Yeah. I mean, you see, self-organization as a principle,
Uh-huh.
it comes from nature only.
Uh-huh.
It comes from biologic, the way nature builds. This you may call self-organization with information embedded in the material. So it's directional self-organization, if you would. We create right set of conditions for self-organization to happen by studying science, right? And all of this has been optimized by nature over many millions of years. And so everything that happens, I mean, we are made together by self-organization, all of it.
But
And the neurons.
self-organization, innately, it has irreversibility within it. Do you agree with that?
Everything is, well, I mean, entropic principle is everything is irreversible until it's not irreversible, which is when you pump in a lot of energy from outside, which is called the open system. So to reduce entropy is a very hard work. Life is actually exceptional in the universe. The odds of this happen are astronomically small, right? Because it just requires such right fine tuning of every possible condition, every constant of the nature, right? This is actually such a subtle thing, and people will not understand it unless you have devoted at least a few months of deep study into what makes life possible, right? So everything has to be so finely tuned that the probability of it to happen in this infinitely cold universe, very small indeed,
Thank you.
infinitesimally small.
Thank you very much.
I will exchange it later. You give me the receipt and where you got it.
Thank you.
Thank you so much indeed. Thank you.
Thank you so much. Now proceeding, next we would like to welcome Professor Kamal Kishore Pant, Director of IIT Roorkee, to the stage. Please welcome him with a huge round of applause. Professor K.K. Pant received his PhD in Chemical Engineering degree from the Indian Institute of Technology Kanpur in 1997. He took over as the Director of Indian Institute of Technology Roorkee on October 12, 2022. Professor Pant previously held the positions of Petrotech Chair and the Federation of Indian Petroleum Industry, Chair Professor, Chairman Gate and Jam, Chairman Library, Head of the Department of Chemical Engineering, and Dean Faculty at the Indian Institute of Technology, Delhi. He is adjunct faculty at the University of Saskatchewan in Canada. He is also a fellow of several national and international academies, which include the National Academy of Science, India, and the Indian National Academy of Engineering. His area of interest is in futuristic technologies for national and international importance, for example, hydrocarbon conversion, biomass conversion, biofuel production, CO2 conversion technologies, and e-waste and plastic management. Let's warmly welcome Professor K.K. Pant for his talk on role of hydrogen in future of renewable energy mix.
Thank you very much. First of all, I would like to thank Professor Behra and entire team of Iit Mandi for inviting me, and it's a very wonderful campus. I had very interactive discussions yesterday evening also, and lot of enjoyment throughout the campus when I visited in the morning. Also, I would like to thank Professor Ashutosh Sharma for delivering again one of the very exciting talk as usual he used to have, and providing the lot of, I think, new inputs for the future direction. Having said that, I have kept my topic mainly related to the technical components of the sustainability, and more I will talk something what Professor Ashutosh was talking about, the hydrogen and biomass, so I'll just cover little bit of that. If you look at, I start my talk from this, which is the vision of India, and also a concept of sustainable energy. So there is always a big difference between sustainable energy and renewable energy, and where the Professor Ashutosh has also pointed out how much waste is produced, right, in every step. That's very important and very challenging, and we need to address that in order to make the entire process sustainable. So that is where already the, sorry, so that is how we'll take it back, I don't know. Okay, yeah. So that's what I was talking about, that how can we take these things, right? You see that energy efficiency and how can you decentralize the energy. These are a couple of very important and challenging opportunities for the future and the younger generation, those who would like to take the research in these areas. Also at the same time, I would like to take this, right, life cycle, and when you talk about, right, because the energy saving is more important than energy production, and that is also, as pointed out Professor Ashutosh. That is the important thing is that at daily routine basis, at household purpose, how much lights are being on, how much ACs are being on, and what we are doing, because in total I talk again a nexus. Nexus is something where we talk about these 17 goals of sustainability, and out of these if you just cover up, this I call a nexus FEW, food, energy and water. And this nexus is interconnected, because if you try to change one thing, if you want to, right, harness the energy, it may disturb the water, right, balance. So that is where you need to look at how this FEW, few nexus, can be balanced, and you supply the sustainability concept is that provide the good quality food, nutritious food, provide the safe and potable drinking water to every Indian society or every citizen of the world, and also at the same time utilize the energy in an efficient way, and that is the where you see that, right, you have to look at or understand all these concepts and then just take the decisions while using the sources of energy or while using any resources, whether it is related to food or water or energy. So having said that, as I was talking about, right, the sustainable energy versus the renewable energy, there is a thin line difference, and when we talk about can we replenish, right? Solar energy we are widely using, we are calling it a renewable energy, but at the same time just think on what kind of solar panels you are using, right? And the kind of the silicon shells which are generally used, just 3 to 5% efficiency, that's a big challenge, right? And what is the life of these kind of materials, and where do these materials go when the life cycle is finished? So cradle to grave analysis is very important in every energy or every process, and that is where you need to understand that when you talk about the sustainability, you talk about the carbon footprint, you talk about the energy security, right? That is again for future we need to understand all these things. So why do we need this renewable energy? Why do we talk about sustainability? I need not to go in depth, but everybody talks about the carbon footprint mitigation. Everybody talks about how much carbon is being consumed and how much CO2 is being processed from these fossil based feedstocks. So you see that, right, what are the consequences of this? The carbon dioxide level. Now we are talking about that, how to mitigate this carbon dioxide. By 2070, how can reduce this carbon to zero carbon footprint, and what are the, you see that, right, ocean acidification, the rising of sea level, and you see the several things, right? In Uttarakhand we hear the cloud busting, right? We hear the Himachal, Uttarakhand, all these, right, hill areas, the landslides, and there are several, right, the glacier melting, and all these consequences are because of the increase in the carbon dioxide concentration or whatever you call global warming. So we need to work for this, and that is where the renewable energy concept has come in picture, that how much is the fossil derived feedstock and how much are the other sources of energy which can be utilized for this purpose. So you see that emission, right, how we have disbalanced this, 3.9 gigaton carbon dioxide, and talking about third largest in the world, and can we reduce to a level of, right, that is where 1 gigaton of carbon dioxide equivalent is to be reduced by 2030 and finally zero by 2070. But how to approach that? There are lot of challenges to make this, and this is where we need, or all of us have to work, and this is where we are talking about the non-fossil derived and based on cumulative electric power installed capacity, all these things, and which are being done at different levels. This is just, I thought that some data I will put, which is already, right, have been discussed maybe multiple times. So this is where we are talking about, right, the installed capacity in terms of gigawatt, right? Just to give the idea, if you have 1 gigawatt of energy, this could power around 8,76,000 households, right? So that's what the approximate number when you talk about the megawatt to gigawatt, and that is where the numbers you see, most of this energy is presently being produced from the fossil derived feedstock like coal, lignite, gas and diesel. So these cannot be, right, banned. That's what very, because we have plenty of 240 billion ton of coal is available, we have to use it. But we have to at the same time capture the carbon dioxide and the overall life cycle assessment in terms of energy consumption per megawatt of energy, if it is a coal gasifier or coal based power plant or look at how much carbon dioxide is being produced, and can this carbon dioxide be captured effectively and then converted into some other chemicals, and that is again, there are lot of R&D are being done in this. So you see here, right, still this 44% of the India's primary energy that is being met, right, through coal. So that's what, right, and we are importing more than 90% of the crude oil fraction. So one thing is that self-reliant India, can we have the Make in India concept, can we have the Atmanirbhar Bharat concept by utilizing the available resources, and at the same time, can we have this technology with carbon capture, and that is again a lot of challenges for the future. So a lot of things are being done, and you see that, right, this is where the target which has been given, the 500 gigawatt of the renewable capacity by 2030, and that is a big challenge to achieve. We talk about power sector, more than 40%, right, of this carbon dioxide, or more than the energy which is required, the major fraction is that, right, and this is where you talk about 40% of the India's emission which is coming from all these power sectors, where generally coal or natural gas is generally used for this purpose, right, and if you have the coal, right, this 65% of this, right, that total carbon dioxide, it comes from the coal, because we are not using any technology for carbon capture so far. If you see that, right, the electricity consumption at domestic levels, because our utilization of energy or our luxuries are increasing, and that is again how many ACs are being used, right, at the household purpose we are using because of this climate conditions, right, for smog and all these things, using the air filters and many new things, and because of that, how these challenges have come, right, that is again, you have to understand that how these things can be thought in an effective way and how it can be utilized in future. So you see that peak load, if you look at just an example of Delhi, when you talk about in the month of summer, it increased, right. So everywhere, whether it is winter season or summer season, we are using either air condition or using heat pump, and that is where the power sectors have now lot of load, and that is where the challenges in terms of the renewable energy which need to find out. So you see that the kind of greenhouse gases which is coming from the power sector, and mainly this is coal-fired power plant, or natural gas is also coming up, but this is where the thermal power plants are facing the challenge, and then there are several industries, transport, buildings, and several other things, and that is the data which you see that how much carbon dioxide is being emitted to the environment because of the utilization of the power. When you talk about renewable, all of you know, I am not going in detail of this, but there are a couple of right things, or a lot of R&Ds are being done, like solar photovoltaic cell. Can we have a kind of new type of devices, perovskite based material are also being tested, so 3% to 5%. So that is the more important, that whatever the existing technology is available, can we change the efficiency, or what are the process by which you can improve the efficiency of the existing process, and at the same time, can we have the new materials which can improve the efficiency and also the life cycle of the process. So these are the challenges, and couple of things, biomass, hydrogen, I will cover little bit on this during this talk because time is limited. So this is where I am not going in detail, but you see that, right, the growth of renewable energy is increasing, right, and that's what we would like to see, an exponential growth instead of a linear growth in this, and that is where you see, right, around 119 gigawatt is the renewable energy, and out of, right, where the 46.85 gigawatt is separate, lot of hydropower based, hydroelectric power based plants are also being utilized, and at Roorkee also we have now the International Center of Excellence for Dams Design, and which is being used for the harnessing the water energy and utilize it for the official purpose. So that is where the data, and you see how these data can be utilized effectively in order to produce these kind of renewable energy sources. So when you talk about the sustainability, when you talk about the sustainable world, everything is important. You see that, right, we have the data here, but at the same time you see here, right, when you talk about the renewable energy sources, how these hydropowers, right, these can be utilized, because these are the greener sources, but again you have to go to back of that, right, how the turbines are being designed, what is the life of those turbines, how the efficiency, when you talk about the system, can be increased. So there are many things where the, I think every branch, when you talk about the multidisciplinary approach, so every branch of science and engineering have to come together and find out the solution for these kind of, right, energy, and how these can be harnessed effectively in an efficient way. That is where the need of the future. So when you talk about renewable energy, as I said, right, the important thing is the environmental impact of this. So these renewable energy sources are also not free from these kind of, you see that, right, what we are discussing. If you look at the solar panels, right, or design of this, a significant amount of energy is required, like mining, manufacturing, right, availability of silicon, like just Dr. Astos was also talking about that. When you talk about the lithium battery, where is the availability of this, what is the life cycle assessment for this battery, every aspect of this, right, the success of these kind of energy devices, whether it is the transportation purpose or production or storage purpose, we have to always do the cradle to grave analysis, and that is where, right, we need to just study hard. So this is, you just see that for this case, whatever the solar photovoltaic cell we talk, there is always also a 40 gram of carbon dioxide per kilowatt hour, which is the equivalent of the coal. That's what we saw. When you compare it with coal, right, coal use 1000 gram of carbon dioxide. So the number is less, no doubt, but still that number, that how many these panels are coming and how much energy you are harnessing in terms of kilowatt hour or gigawatt, that you have to calculate. And then again the question comes that how that carbon dioxide can be minimized, or in what way the life cycle assessment of this impacts the overall environment. That is important here. So there is a solution also. So people are talking about the recycling of the solar cell materials, but to what extent it is being done, that is again a challenge, right? And this is, if can be done, you can have 42% reduction. So complete energy audit is required for a given process, and that is where the tools like artificial intelligence, machine learning, this should be used, right, for these studies, because data are available, and from the existing data, how can we identify the new technology or new process, and then we can design or devise a new system. You see that the photovoltaic cells, if you look at the waste volume, it has gone 200,000 tons by 2030, that is the prediction. Right, and that is again a challenge, because large number of these photovoltaic cells which have the efficiency 3 to 5%, and after that you are just putting it in a dump. So landfills is again a problem. You cannot create those kind of landfills, right, for the luxury of ours, right. We have to look at our future generations, right, and for that also how much the earth, green earth we are maintaining, or how the climatic or economic sustainability we are maintaining is important, and that is where we need to understand all these factors when we talk about this process. Household purpose, I am talking about building, right. Everybody is using large amount of luxuries in the building, and nowadays you see 1/3 of the greenhouse gases emission share is because of the building and the construction sector. This is again a challenge. We are, right, creating the large buildings, and that is where, right, how much power. So are we thinking about the green building? So that is again the new design, new architect has to come in picture, where the green building concept, or in the daytime avoid the using the lights, or, right, whenever there are the sources. So that is a kind of social awareness is very important. We have to train our young generation, we have to make the society aware that if you are using or lighting these lights, how much energy, right, is being consumed, and because of that how much emission, and how your next generation will be affected if you are not, if you are using that, or if you don't use that, right, what advantage your next generation will have. So these things are very important, and that is where the future, you see here, right, the building is that whatever the number of constructions, and they are consuming the huge amount of energy. Lot of malls are there, right, everywhere you have the, during daytime also the air conditions are running, and what is the impact of those, right, on the carbon is important, and on the carbon dioxide emission. So lot of things we need to understand, that how can we do that. So there are a couple of new things, right, like in Himachal area, the geothermal energy, right, it could be, it is considered as a much better than the solar and wind energy, and the power can be harnessed from this, and there are technology, you can have geothermal is something where you have the, right, under the earth crust, whatever the, right, the changes happen, and because of that the heat is generating. If you are able to harness that heat in the form of steam and run the turbine and generate the power, so that could be, I think, the options. And you see here the many areas where this geothermal energy, right, can be utilized, like Himachal Pradesh, Gujarat, West Bengal, Chhattisgarh, Maharashtra, Jammu and Kashmir, and these sites have been identified, and the energy utilization is again an important from this source. Then another, as I said, at IIT Roorkee we are working on this, and for Tari Dam we have done this work for hydroelectric power, so you can have the kinetic energy of water, and that can be utilized, right, and that is again a green source of energy, and one of the important example of renewable energy. I want to talk something on this because a lot of discussions have come on this biomass, renewable hydrogen, right? And you see that now the green steel concept, right? When you have the biomass, you can convert into biocoal, and that coal can be blended with the, right, whatever the fossil derived coal, and then at least you are saving the part of the carbon energy. Because overall life cycle assessment talks about the biomass is considered as a source of green hydrogen also. Although the green hydrogen, when you talk, it is generally assumed that it is just through the hydrolysis of the water, right? That's a, but where is the availability of that kind of water? If you can use the saline water, that is the best thing. Otherwise, you have to again take the water, purify it, right, distill, deionise, and then you are doing the hydrolysis. Then again, there is a consumption of energy, and the process is not totally green. So, a lot of things are there. But these kind of, right, if you have this kind of analysis and do complete life cycle assessment, then you can have this biomass into a by pyrolysis, that is a liquid, gas, everything can be generated, and that is something like you can convert it into hydrogen also, and that is the green. So biocoal, lot of these are the traditional methods, right? For domestic household purposes, these were used earlier, right? And the same thing can be technically you can modify it by technological right development, and that can be a good source of energy. So when I talk about the biomass or green hydrogen, everybody must have heard about that, right? Why do we talk about this? If you just see the second point, right? 1 kg of hydrogen is equivalent to 7 to 8 kg of the coal. So you are reducing the mass of the system. Although when I talk 1 kg of hydrogen, you can calculate what is the volume of that 1 kg hydrogen, because gas has the density of order of 10 to minus 3, right, in terms of gram per centimeter cube. So that is a challenge, that how will you store that mass, right? So that is a challenge. Or can you have directly, right, transfer it into the energy without storing? So transportation and storage is still a challenge, and that is where but if you can do, right, that is the big advantage with the hydrogen, and this is a totally a green fuel which can capture the, right, carbon dioxide from the environment. At the same time, when you are using the renewable sources, that is one of the best options. So you know all these things, I am not talking in detail because of the time limitation, but you see that this kind of renewable sources, like whether wind, solar, biomass or hydro, geothermal, anything can be used for producing this green hydrogen or clean hydrogen. That is where the future demand, and that is where the hydrogen can be used in process industry large amount, and also it is used as for the vehicular application. So it is much better than the e-vehicles, right? Because in e-vehicle you are using the battery and you don't know what is the future of those disposed battery, how to dispose it or how to recover and recycle. That is a big challenge. But if that comes, that would be good. And hydrogen, you know, the industry demands again a large amount. So that's why the steel industry, NTPC, all they need now biocoal, the hydrogen for their process industry. There are, right, when you talk about hydrogen, right, you see that, right, it can be from both fossil and renewable energy, but with carbon capture, that is very important. Storage and transport, people are working on this, although it is a challenge. And right, when you talk about stationary mobility, all these fuel cell application, you have the hydrogen, and that's why the hydro, right, this is the water, and you can have the again hydrogen, you can drive the vehicles. The challenges are there, policies are to be made, and lot of work is being done, right, by government in these directions. So these are a couple of ways by which we produce the hydrogen and store, and this is where you see that traditional coal is generally used, but you can mix the coal with biomass, and that could be, or purely you can have the biomass here, and then you have the gasification or oxygasification or pyrolysis and reform it. So you can have the different kind of these products, right? So that is where you see, right, the syngas is generally carbon monoxide and hydrogen, and then you can have what you call high temperature shift and low temperature shift. And this CO plus, right, the carbon monoxide and H2O reacts, and from that you can have again hydrogen. At the same time you have to remove the carbon dioxide here, and then you can have hydrogen, and right, and this hydrogen can be stored, and that is where the 99.9% hydrogen can be produced. And this is a kind of technology which is required for the future, and this can be done whether from coal, and coal to methanol, biomass to methanol. There are a lot of things are being done, right, or the policies are being made in this direction. And this is again, when you talk about fuel cell delivery, you see that, right, the energy analysis is very important, and how can you do a complete exergy analysis in order to make the process more efficient. You see just an example here, right, what the Professor Ashutosh was also talking about, AC versus DC, right. So although the DC has lot of complications also, and if that can be resolved, definitely this is better. But otherwise, these both things, the efficiency cycle, so there this is missing, this is around 56% efficiency cycle for this. But if you are rejected heat, something like heat pump, and if you are able to recover that heat pump and then transfer and utilize it, then you can have the additional 25%, and this is where we are talking the 50% efficiency cycle in this, and that is where if you can harness this energy, this can be increased to 75%. This is where I think the design is important for the future, that the fuel cell which are 50 or 60% efficient can be raised to a level of 80 or 90%, reach towards the thermodynamics level, and by doing this exergy analysis. So wherever the losses, wherever the entropy losses are there, try to capture and then put it in the system. I think that would be one of the best option to save the energy, to increase the efficiency of the process, and that is the important for the design for future also. So there are many processes which are hydrogen generally produced, but we are talking here the green hydrogen, and that is where the lot of challenge, whether it is water electrolysis, and then electrolysis will require the solar energy, something which is green energy, and then that's complete life cycle assessment will call it a green hydrogen. If you don't do that, you have the traditional hydrogen which is called gray hydrogen. You don't capture the carbon dioxide from there, and that is going to the environment, and that's why people are trying to work with the fossil derived feedstocks also, and capturing the carbon dioxide, which may be called as a blue hydrogen also. And people are using nuclear energy also for this purpose, for water electrolysis, and they call it pink hydrogen. So I don't go with these color codes, but more important is that how much hydrogen you can produce, with less energy input and zero carbon at the output. So we have done a lot of work on these, like biomass, you can have the plenty of biomass available in these areas, This is, I'm talking about plant and leafy biomass, or it can be a kind of kitchen waste also, which is converted to biogas, and then you can convert it into, the reform it, you can have the biohydrogen from there also. And that is where you need to see, the oxy, these gasifiers. So we were working for this, one of the DST sponsored project on coal to methanol, and then we are working now this biomass based process for this. And this is similar concept, you gasify it, and then you have the, you remove all these things, and then remove the tar. Biomass gasification has one of the challenge, it produces a large amount of tar, and that tar can be reformed also, but you have to calculate again how much energy is consumed for reforming of that tar, because it is very carbonaceous carbon material, thick material, and very difficult to reform under normal conditions. But these can be done, and you can have the gas cleanup, and then do water gas shift reaction, and then you have again the hydrogen, and this is where the compressed hydrogen can be produced. And typically 1 kg hydrogen can be produced from 12 to 15 kg of the biomass, that depends on the type of biomass. So lignocellulosic biomass would give you the better quality of this hydrogen in terms of the hydrogen produced per unit mass of this kind of feedstock. If you are lignin rich, you can convert into carbon, and that carbon can be utilized for multiple purposes like battery application, and people are working on that also. So future is something here. I am not going again in depth of this, but you see the currently we are using, what is said here, the cradle to grave efficiency via hydrogen pathway, that is renewable energy plus fossil fuel. But future will be something here where you talk about all the things, instead of this gray hydrogen, blue hydrogen concept can be used, and everything will run through these kind of hydrogen based technology. And for producing this hydrogen, you can use any source of renewable energy, and that is where the trend for the future, that either you use the fossil derived feedstock, then do the carbon capture, otherwise use the renewable energy feedstock, but again do the cradle to grave analysis concept. So that is where the hybrid type of system will also work for this kind of technology. So that I have already discussed. So this is where you see, the hydrogen pathways are coming up in a big way, and I think lot of hydrogen buses are also being run, and lot of work is being done in India, at different sectors, and that is where you see that heavy transportation, even the hydrogen based aircrafts are also being designed, and now DRDO is also working on that for the army application. There are different kind of hydrogen based vehicles which are being developed, and that is where I was talking steel plant, gas network. So everything where you talk about, you have the renewable energy, you can have the seawater even also, that the you can have, you do have the distilled deionized water, but direct electrolysis of the seawater is also a new R&D area where the R&D can be done. And then you have the green hydrogen, which is 99.9%, and this is where the perfect the area if the renewable energy can be utilized for hydrogen production. And that is people are, because storage is an issue, people talk green ammonia also, so hydrogen can be stored in the form of ammonia, and then these ammonia can be used for fertilizer industry, or green hydrogen can be used for multiple applications. So there are a lot of opportunities if the hydrogen is produced, and if the hydrogen is green, and that is where the carbon capture is important for the future. So this is a new area, people are doing lot of work on this, direct electrolysis, but presently the cost wise this is not very effective. So how much hydrogen? So on an average it is said that 120 to 130 rupee, that's the ideal per kg of hydrogen. Reliance has targeted $1, so 80 rupees per kg, which is I think quite optimizable, but future will talk about. Presently the cost of hydrogen from here is around 300 rupees per kg. So 120 versus 300, that's what the challenge. So overall economy of the process is also important when you look at the utilization of hydrogen effectively. So lot of things are to be done in these areas, When you talk about the these kind of electrolysis, solid oxide electrolysis, or anion exchange membrane based fuel cells. So these are already in picture. But important thing is that how the efficiencies of these process can be improved, and that is where you see how much is the hydrogen, how much is the CO, and that is where the approximate you talk about 3.1 kilowatt hour per normal meter cube of this kind of syngas, But this is number is to be increased, and that is where the challenge is, where we are talking about 4.8 kilowatt hour for 1 normal meter cube hydrogen, and that is the output at 30 bar. Can this number be reduced further? 3.5 kilowatt hour, That's what there are a lot of things to be done to reduce these numbers, and that is where the efficiency of the process will improve. So that is where lot of things are to be done when you talk about the electrolysis of water for green hydrogen production. So we did some kind of energy analysis for this. You see that roughly when you talk about this energy analysis, you talk in terms of at every step, which is not difficult, just by thermodynamics, calculation, or adiabatic compression, you can calculate, how at 60 bar this talk takes around 3.8 kilowatt hour per kg of the hydrogen. That is the energy required to compress, and that is when you talk about the cycle efficiency, this comes 92.2 by this compressed hydrogen when you talk about this. If you just improve the process, sometimes we talk about methanol, because methanol can store hydrogen, it is high density material, so that's why the efficiency of this process is 79. So whether you would like to go 92 versus 79, it is the understanding about this, can it be pressurized and transported easily at 600 bar, so that kind of vessel, a carbon based vessels are nowadays being developed, the carbon nanotube based material for storage of hydrogen, but 600 bar pressure storing hydrogen, and how will you take it to the vehicle purpose or some other purpose, that's again lot of things are to be done in these areas, and that is where the conversion efficiency, capture efficiency, and compression efficiency, if you tune this process, then I think there are lot of advantage, because saving energy, improving the efficiency of the existing process is more important rather developing the new process for the future. So this is what I am not going in detail, but you see that, when you talk about the green hydrogen using renewable electricity, biomass, waste, and that is where you need to understand the cost targeted 100 rupee per kg of hydrogen, and these are the challenges which are to be addressed for the future, and renewable energy will play again very important role for each every step, and life cycle assessment of this process is also important. So just very quickly, I am not going in detail of this, but this is what we are doing, and we would like to see Iit Mandi and other IITs also to collaborate, because these are the kind of Tata Steel or NTPC, they want 100 ton per day of this bio coal from this process, and they want to mix it with the coal for their process industry. So that is where, similarly for the the battery application requires the hard carbon. This is the way, from biomass you can generate the hard carbon. So a lot of things are to be done, and these are the couple of activities being done. This is again the hydroelectric grid, which is being done at IIT Roorkee, because International Center of Excellence for Dam, that is where we are working with Ministry of Jal Shakti, and using this as a source of energy, and this is what the Tehri hydropower complex, right? And this is being utilized now at the Tehri dam. Then there are a couple of, right, this power just because that is where the startups have to come. Young generation have to work, right, how the, right, ideas can be generated, and then how these ideas can be taken to a next level, and how this can be commercialized for the future. So a lot of things are to be done in these areas, right. So again the, right, stress is that you have to think on this. When you talk about renewable energy, you talk about solar energy, you develop the photovoltaic cell, but at the end you have to look at the life cycle assessment. How much waste is being produced from each of these processes, and that is, right, you have to work, right. And again, you have to look at whether sometimes we just talk in terms of the output, but input and background information is also important, that how much water is being consumed in every process, right. That was what Professor Ashutosh was addressing, right. So large amount of water, because FEW, food energy water nexus, is to be addressed, and that is the concept of sustainability, and that is where everybody has to work on these all areas, that the waste minimization is very important, right, energy efficiency for each process is very important, and we need to work. So that is where, right, there are advantages of renewable energy. We are thinking that, right, if this can be done, it can give the job to many, because there are many opportunities. Renewable energy sources requires large amount of manpower, and that is, right, an opportunity for creation of the job, right. Do you see that you need to train the people? So that is, again, you have to understand that how the skill development program would be important, and every IIT, every NIT have to work for these skill development program, and these kind of programs should also be, right, a brainstorming session, how energy resources can be utilized efficiently, and this should be done at household purpose, right, from household, right, itself. And we should train our younger generation that how to save the energy at every step, and what would be the consequences. Some calculations can also be given, right, how much food you are wasting, how much water you are wasting, how much electricity you are wasting, and if you can save that, right, how your future generation will be comfortable. So that is the ethics and, right, the concept which is very important, and everybody should learn that. So this is where we talk about environment, sustainability, renewable energy, climate changes. So everything is important when you look at it, and that is the India is facing the twin challenges of energy and environment. I had the option but to work towards increasing the role of renewable in the future. We have to look at the environment impact and how much energy is being produced, and that's what the overall balance is required, and along with, right, the other sources which are being used for the process development. So I always talk about these, right, the essence of dilemma, right, when you talk about the energy economy environment, and this is where the, right, we need to understand everything in one loop, right. So what is the impact of the process developed, what is the economy of the process, can it be commercialized from that point, and what is the impact of that technology onto the environment, that is important, and then if this is, we can utilize the entire process successfully. So with this, just I stop myself here because of paucity of time. I moved little bit faster because I was asked to finish the talk in 25 minutes. Thank you very much. Yeah.
Thank you, Professor K.K. Pant, for the thought-provoking talk. I would like to request Professor Chayan Kanti Nandi, Dean of Resources and Alumni, to honor Professor K.K. Pant with a memento.
Is there any question? You can, I'd be happy to answer. Yeah.
Sir, my name is Bhavesh Bisht, and I have this question in my mind from a very long time. So we in India are sitting on a very large stockpile of thorium. It's way cleaner fuel than uranium too, but still in the last decade there has been very less research in this sector. Why is that? Do you think that there's some kind of international pressure on India after Dr. Homi Bhabha's death?
No, there is nothing like that. See, of course, when you use the nuclear energy, there are a lot of things in terms of the safety of these kind of processes are important. And in India, if you look at very limited, like BARC is doing a lot of R&D, DA is doing a lot of R&D, and probably in future you see that, right, there are around 6.8 gigawatt of the nuclear energy already being utilized. And nuclear energy could be one of the green sources of energy for the future. And if India can utilize, right? I think the major component of this energy crisis will be solved because of that, and then we will be less dependent. But at present, most of this R&D is at research level. There are, see, mainly when you talk about the nuclear resources, you have to understand the safety aspects of the entire process, right? Because the Japan, you have seen the example couple of times, right? So when you see that, how this entire nuclear energy can be used effectively, I think that is more challenging, and if that can be done, I think that will be a future. And this is being done. It's not like that no research is being done on nuclear energy resources, and that is already being done. And fast breeder reactors, they are using, right, for lot of the atomic application, but soon I think there are couple of power plants are also being run on this nuclear. The capacity wise they are not that much. Sooner I think in future there will be the more power plant based on the nuclear energy also.
So thanks a lot for answering my question.
Yeah.
गुजरात में मुनि सेवा आश्रम में दीपक गाड़िया के एक कंपनी है उनकी, उन लोगों ने 500 स्क्वायर मीटर की एक सोलर थर्मल डिश बनाई है। अगर ऑस्ट्रेलिया की एक यूनिवर्सिटी इंडिया के साथ कोलैबोरेट करके एक 500 स्क्वायर मीटर की वो डिश बना सकती है, जिसको हमारे भारत के सभी ऐसी इंडस्ट्रीज़ में, रेजिडेंशियल कैंपसेस में, बहुत सारे हॉस्पिटल में ऑटोक्लेव और मेडिकल बहुत सारे उसके में यूज़ करने के लिए, तो मैं सोचती हूँ कि आज मैं इतने आईआईटीज़ के बीच में बैठी हूँ, तो मैंने सोचा मैं ये कहूँ कि आईआईटीज़ जिसके बारे में सोचें उसका नाम है बिग डिश। और दीपक गाड़िया जो भारत में जर्मनी से शेफलर डिश लेके आया था पहली बार, आई थिंक इट वाज 90s, उसके बाद बहुत शेफलर डिशेस बनी और एमएनआरई ने प्रमोट करवाई थी, हम लोगों ने टेस्ट की थी, और सिर्फ हमारी ही इंडिया में एक डिश थी जो 10 साल के बाद चल रही थी। तो अभी आज भी चल रही है वो एक सोलर डिशेस जो मेरे हस्बैंड ने बनाई थी, जो कि इंजीनियर नहीं थे। लेकिन मैं ये कह रही हूँ कि इस तरफ एमएनआरई ने डिलीट कर दिया उसको, पूरे सेक्शन को, क्योंकि ये जो आपने तो क्लियर कर दिया कि ये फोटोवोल्टिक एनर्जी जो है ये अल्टीमेटली सस्टेनेबल नहीं है। तो हमें बैलेंस, मैं ये नहीं कह रही कि उसको नहीं होना चाहिए, एक बैलेंस सोलर थर्मल पे कोई भी काम क्यों नहीं हो रहा। हमने गांव में हज़ारों सोलर कुकर पैराबोलिक यहाँ पर जो बाहर रखा है, उससे अच्छे वाले थोड़े से और वो पहुँचाए और महिलाओं का जीवन बदल गया उससे। सिंपल 15,000 का एक वो है। तो मैं सोच रही हूँ इस दिशा में आईआईटीज़ को काम करना चाहिए, मेरी ये रिकमेंडेशन है, मैं आपसे क्वेश्चन नहीं पूछ रही हूँ। थैंक यू सो मच।
थैंक यू मैम। आई थिंक मेरे ख्याल से काम हो रहा है, ऐसा नहीं है कि सोलर एनर्जी पे काम नहीं हो रहा है, और हर आईआईटीज की अपनी बिल्डिंग में सोलर पैनल लगे हुए हैं आजकल, ज़्यादातर आईआईटीज में सोलर थर्मल के भी लगे हुए हैं, सोलर थर्मल भी लगे हुए हैं। आप थर्मल एनर्जी की बात कर रही है ना जी, वो भी एक्चुअली सोलर थर्मल डिशेस की इफिशिएंसी बहुत कम है। तो इस जो नहीं, गलत बात नहीं है उसमें मैडम, उसमें ये है कि 3.5 to 5% इफिशिएंसी पे चल रहे हैं अभी ये ज़्यादातर। अब हम बात कर रहे हैं जो मैंने पेरोव्स्काइट मटेरियल की बात की, जो 35% इफिशिएंसी आती है, तो वो अगर वो मटेरियल डेवलप होंगे तो आपकी इफिशिएंसी ज़्यादा आएगी। नहीं, रिसर्च हो रही है, सोलर रिसर्च बहुत हो रही है, सोलर थर्मल में बहुत रिसर्च हो रही है। नहीं, आईआईटी दिल्ली में हो रही है, आईआईटी रुड़की में हो रही है, और आईआईटीज में भी हो रही है। मैं आपको डिटेल भी दूंगा इसके, और इसका आउटपुट भी आपको दूंगा मैं। अभी क्या है कि हर कैंपस को ये कहा गया है कि वो सस्टेनेबल हो, सेल्फ सस्टेनेबल हो। अब जो मेनली आ रहा है कि जो सोलर एनर्जी स्टोर करके बैटरी में भी स्टोर कर रहे हैं आजकल, वो भी हो रहा है। मतलब ऐसा नहीं है कि जब सोलर सनलाइट है तभी एनर्जी आ रही, सोलर एनर्जी से लेके उसको बैटरी, ज्यादातर फोटोवोल्टिक पे है, लेकिन थर्मल में भी कर रहे हैं। हाँ, अभी थर्मल में भी कम हो रहा है, कम हो रहा है, क्योंकि लोग फोटोवोल्टिक सेल की ओर आ रहे हैं।
को वापस जिंदा करे जो माथुर साहब के जमाने में थी। अभी माथुर साहब खुद ही कहते हैं कि गवर्नमेंट की प्रायोरिटी नहीं है।
हाँ वो है क्योंकि
तो इस कॉन्क्लेव में आकर सोसाइटी के लिए, साइंस के लिए मेरी एक सोशल वर्कर की
I think Professor Behra से I will request कि just look at right pro and cons of the process and then we can work on that. क्योंकि लोग directly अब photovoltaic cells are easy right to design, easy to implement compared to thermal and that's why people have moved to voltaic. Efficiency कम है तो लोग efficiency बढ़ाने की बात कर रहे हैं but this also is very important. वो भी हो सकता है जी। नहीं नहीं उसको अगर कोई टेक्नोलॉजी है तो मेरे ख्याल से एमएनआरई के आने वाले थे ना, आए नहीं हैं तो वो भी डिस्कस कर सकते हैं कि उसमें क्या रीजन था, वो बता भी सकते हैं डिटेल्स में तो हाँ डेफिनेटली थैंक यू थैंक यू वेरी मच।
Thank you so much, ma'am. Thank you so much, sir.
Thank you. Thank you very much. Thank you.
Next, we welcome to the stage our esteemed guest, Dr. Kinshuk Banerjee, Director of Hitachi India Private Limited and heads the R&D division in India. Hitachi is committed to societal development and the creation of social, environmental and economical values for its customer and ecosystem partners. It is actively engaged in developing an ecosystem of government, industry and universities for business alliances in India and around the globe. Dr. Kinshuk leads the efforts in India through quantitative research and innovation. Prior to Hitachi, Dr. Kinshuk Banerjee was a partner in IBM Consulting, where he led the delivery of cognitive business decision support services worldwide. A computer science graduate by training, he earned his doctorate in engineering management from George Washington University, USA. Dr. Kinshuk Banerjee is certified by Cornell and Harvard Universities in executive leadership and change management. Let's warmly welcome Dr. Kinshuk Banerjee on the stage.
Use this.
Hello. Yeah, this is good. And I can go like this, right? Okay, thank you very much for the audienceship here. Thanks a lot to IIT Mandi and all the distinguished audience out here for making me part of this very distinguished panel. So let me discuss a little bit about the sustainability, renewable energy, the circular economy landscape that we currently see in the world as well as in India. So I am from Hitachi. I lead the Hitachi India R&D. Been working in artificial intelligence systems, computer systems for a long time. And after the wonderful discourse that we heard from our predecessors, I will focus more on application of AI, artificial intelligence, and platforms, computer science systems, what they can do today to optimize energy in this world. So this is a little bit different, not exactly the chemistry, not exactly the physics. It is more about management of such systems. So very quickly, if you look at the carbon footprint, the massive thing right at the soul out here is the industry. 19.6, 20% of the carbon is being produced today by the industry. So if you have got to go and reduce, can you hear? Yeah. So if you have got to reduce the carbon footprint today in the world, we have got to start first with the industry. There's no question about it. Now, so just hold on. Okay. There's a little bit of a sequence problem here. Okay, so few things. There are a lot of school kids that I see here. So there are three things I want to ask. I want to first clarify. First thing is the climate change. The second thing is the net zero. And the third term is sustainability. All these things are very important keywords for us. If you look at climate change, what is our current collective goal? If we get more than 1.5 degrees Celsius from the 1850, 1900 year, that Earth's surface temperature baseline, whatever it was actually somewhere around 15 degrees Celsius. If we get 1.5 degree more, we are in real trouble. The temperature is going to increase so much in our cities, the glaciers will start melting. This is going to be a real bad thing for us. So we have to do something to contain this climate change, this upward climbing graph that the heat temperature index we are seeing today. To do that, one of the first things that we have got to do, we have got to reduce emissions of carbon dioxide, methane, nitrous oxide, a whole bunch of greenhouse gases that today contribute to this warming, global warming. Now, whatever we emit, that much we should reduce. That's a tough thing, but this is what we must do. And by 2050, 2060, we must get a net zero. And finally, there is the sustainable. We have to make this work sustainable, not only about the carbon, but also about the raw finite material. How much can you go and keep mining copper, nickel, cobalt, all these things from Mother Earth? At some point of time, We have got to stop this. And we have got to think more about recycling what has come up on the earth's surface as opposed to, delving deep into the bowels of the earth to get more. So three things. One is, of course, the carbon management. We have got to reduce the carbon emission. Second thing is, we have to think about circularity. For a long time, last 50 years, people have been using use and throw kind of policy. They manufacture a lot of semiconductor-based material, radios, televisions, we have been doing, we use, we throw. How can we go reuse some of it? That's the second thing. A very age-old wisdom that we had in this wonderful country, we have got to bring that back, but of course, in a scientific way. And then, of course, the third thing is, we have got to measure, monitor our progress. How do we know that we are doing well? We have got to measure it. We have got to monitor it. And that's where the new world of connective industries, sensors, artificial intelligence, computer systems comes in. They come in because they help you to measure, monitor, put it on a platform, and come up with insight generation from time to time. Okay, we looked at the carbon footprint. So, few things. Not only we have got to reduce the footprint, we have got to reward the people who are polluting less, and we have got to punish them somehow, the guys who are producing more than what they are supposed to. So that's carbon offsetting. We'll talk about, and neutrality. How do we get there? So here the greenhouse gas come from. Methane, 27 times more harmful from the greenhouse effect perspective than carbon dioxide. Though it's not that stable though, and hence in the environment, and hence we tend to go and measure everything, all emissions, with respect to carbon dioxide. We call that carbon dioxide equivalent, CO2e. 1 kg of CO2e. So all other gases kind of, map to carbon dioxide equivalent. That's how we measure them. Now, if you look here, fossil fuel combustion, and even the cow blobs, the animals and all, the way we live our life today on this earth, it makes a lot of, introspection. Now look, here is the question. There is a light bulb. How much do I save by turning off the light bulb or by lowering the thermostat by 1 degree Celsius? We cannot answer this question until and unless we start measuring the emission output of these two systems. Hence comes the sensors, hence comes the data world, hence comes the platform, like your Amazon platform, like ONDC platform, like the eBay platform, wherein you go and spool in all that data from different sources, different places, different devices, different ages, and then you start computing them. Now look, here is one thing. I was talking about that equivalence. Carbon dioxide equivalent to methane, nitrous oxide. These are some interesting stats. You can take a look at it. Now comes the very important thing. You have carbon. You have got to go and measure the footprint of the carbon. Now to do that, now you have got to account for it. And not only you saw, like the industries do that. We, Hitachi Corporation, we are also one of the polluters, though we have a very strong imposed standard, but that doesn't mean anything. At the end of the day, we must know how much are we polluting, how much are we emitting, like everybody else, right? So there are three ways the carbon accounting is done today. One is scope 1, scope 2, scope 3. 3 scopes we call that. The best way to remember it is burn, by, and beyond. First is burn, scope 1. Here, for example, you are producing steel. while producing steel, you will have blast furnaces. You have a whole bunch of, you have blast furnaces, you have a whole bunch of processes that consume a lot of energy, emit carbon dioxide. That's your burn, scope 1. We have got to measure it, and it is a little bit easier because these processes are under our control. Next is scope 2. While producing steel, we consume electricity, and the electricity itself has got its own carbon footprint, whether you buy it from the local electric supply corporation, or usually we always do that, we procure it from outside. We have got to tell them, hey, tell me the amount of electricity that you are supplying. I know the units. You tell me for each unit of that electricity, how much you are emitting today in this world. And the third is everything else, beyond burn and buy. What is beyond? That means all other procurement sources. I am procuring, for example, raw material for steel, or the people, this is called downstream, and then there is the upstream. And so basically the people from whom I procure and the people whom I sell. What is the total carbon footprint happening there? And this is exactly what Professor Pant was talking about, cradle to grave. Whenever there is a product, whenever there is something, we have got to start measuring it right from the source till its end of life. Towards this whole process, how much do I go and how do I account? And that is important. Now, while doing this thing, not only for, okay, so I'll come to that later. Let me go a little bit faster. So what is, now this is interesting. Now that I have accounted for carbon footprint, and I have come up with a policy that I am going to reward the people who are producing more carbon emission than they are supposed to, and the people who are producing less carbon emission than they are supposed to, I have got to reward and punish these people. Guys who are polluting, you have got to punish them, and the guys who are producing less, you have got to reward them. How do you do that? So you now come up with a pricing for all the extra bad things that you are doing and the extra good things that you are doing to the society. And you need a government intervention. And very often we see there are carbon pricing and carbon trading platforms that they have been put by the government. So they say that, look, we are going to go and do something called carbon taxing. If you are doing more than what you are supposed to do, if you are a polluter, you have got to pay the tax, and with that tax money, I am going to do something good. I am going to plant trees here or in Amazon rainforest and make the earth more beautiful, because the more plants that we have, they absorb more carbon dioxide and then reduce some of the carbon dioxide footprint in the environment. So I will impose a tax on you, and with that tax I'll do good. So that is what the government is doing. Now suppose government says that, look, I will set up policy. I am government. My job is not to govern. My job is not to do business. So let us do something interesting. Let us create something called carbon trading platform. And we'll talk about that in a moment. But the moment you do carbon tax in economics, there is a very famous principle called substitution effect. People start saying, okay, I have been producing carbon doing all these bad ways, the blue ways or the gray ways, like you heard from Professor Pant. There are gray hydrogen, blue hydrogen, and then there is a green hydrogen. I am going to go and switch from this more expensive process to something better process, where I may spend more money at the end of the day to produce this, but because of the tax benefits and all, I will get, or because of the punishment that I will be spared, ultimately I'll spend less. So let's go and switch onto a better way of producing my energy. So that's called the substitution effect. Whenever the price goes up in some place, you substitute that procurement by something cheaper. Now, here is something very interesting. 1990s in US, they tried. In Europe, in 2010, in the first 10 years of 2000, they tried in Europe. This is something called ETS. ETS is an emission trading system. What it does is something very interesting. You can go and buy your right to pollute in some ways. But the moment you buy your right to pollute, you have got to pay some money. So somebody has got to go and do some good with that money. So this is called carbon trading system. You can go and say, okay, look, every year, given the kind of steel, the Tata steel that I'm producing, I have to pay, say, I can produce, say 5,000 metric tons. Now, without 5,000 metric tons of emission, instead of, I will be doing this year 5,600 metric tons. So that 600 metric tons worth of carbon credits, I am going to go and buy from the emission trading system. Now, that 600 metric tons worth of carbon credits must be supplied by somebody who is either producing less or doing something good, like that forestation. And I'm talking about not only forestation, there are many other ways of doing good to the society today. We can directly try to capture carbon from the environment. You can store it, CCAS, we call it. You can store it in biochar. The different kinds of ways we can try to store the carbon and for future use for a sustainable period of time. If that carbon dioxide again comes back to the environment in 2-3 years, it does not work. There is something called sustainable farming, which is being done today extensively in California, in France. What sustainable farming does is you take the carbon dioxide, you basically put it under the soil and you keep it there. But the most important thing out here is that again it should not, through water or some other means, it should not come up and go to the surface. And there are ways to measure and monitor it. This is where computer science, IoT, Internet of Things, the sensor-based technologies, all these things are playing a vital role, and a platform is playing a vital role. The good that you say that you have done today is not just at this moment that you are doing the good. It has to be sustainable for next 10 years. So my behavior has to be monitored for next 10 years so that I keep on doing that good. It is not an instantaneous one-time good. So that has to be monitored. Okay. Now, the carbon offsetting, it works this way. Now, this is a very famous thing called cap and trade system. In cap and trade, you have a cap or a ceiling on the total amount of carbon credits that you can use in a country or for an industry. And that's what the most prevalent trading system that we have. One important thing, trading does not mean that really the carbon footprint is going down. Because at the end of the day, we are putting a price to these activities. But there are people who may cheat the system, who may game the system, and as a result of which, people take money from you, but they don't do forestation. Then they don't really produce any carbon supply, which means my carbon emission in the footprint in the environment will keep going up. And that is a big problem today worldwide. How do we make these systems fair? How do they really work on this kind of? Hitachi's, for example, this is a very interesting thing, to do the emission tracking of the $80 billion industry that Hitachi today is. We produce transformers, we produce compressors, we have semiconductors, we produce bullet trains, we have artificial intelligence, we have a whole bunch of things. All these things are producing a lot of carbon emission in all aspects. So we must have a tracker ourselves to go and do this kind of thing. If some entrepreneur here from computer science or electrical department comes up with a platform and sells it to their enterprises, That's probably innovation. And by the way, I very much thank Professor Ashutosh Sharma for making a fantastic distinction between invention and innovation. So that is, there is your knowledge, and you turn that knowledge and you make some money by selling it to the other companies. Okay, now let's get some facts and figures very quickly. Decarbonization is driving renewables. I'm going to skip the video. If you look here, these are PricewaterhouseCoopers. They are clearly saying, if you look at the United States and European Union over here, more and more they are moving towards the renewable source of energy. If you look at India, we are also moving up, but it's going a little bit slower, but we will be there. And China, if you see out there, is already spending a lot of money in the renewable energy today. It's amazing to see how the Chinese solar companies, for example, they are flooding the market with cheap solar cells and some of the components. Now, the breaking down of the renewable sector, hydro, wind, solar PV. Of course, wind is more expensive, but we do in Hitachi a lot of work with wind turbines. We'll talk about that. And then there are the solar PVs and the other bioenergy. This is the expected shift in the energy vectors around 2030. And if you see here that clearly hydrogen and EV batteries are making a lot of sense. You heard from Professor Pant a lot of very interesting discourse on hydrogen, on the fundamentals of hydrogen working. We are all working towards that. And to tell you the truth, not only aeroplane industry, which is expected to adopt hydrogen in a big way, it is the cars, the automobiles, the Toyota, the Honda, we all expect them to get. There are problems with the hydrogen vehicle today. I mean, the transportation, the safety, some of the things that we have to take in consideration. But at the end of the day, the energy content is so high. And if we can produce green hydrogen, not the gray or the other ways of producing hydrogen, we would be really, really in a very good shape in decarbonization. Electric vehicle batteries, a very interesting thing, but the most important thing out here is the availability of the components, lithium, cobalt, a whole bunch of things, copper, that are going into electric vehicle production today. They are in short, and you can clearly see that they are in short supply. Because if you go for XUV Mahindra or Toyota ZX, the latest variety, you will be waiting at least from 6 months to 2 years because there is no component supply. So that's why circular economy is so important for the sustainability and reliance of this country too. Okay, now, and the models are converging, and this is bound to happen. The molecules, the electrons, for all these days, we have been looking at the chemicals, oil and gas, power and utilities as separate entities. And I was listening to that argument. Indeed, the oil and gas lobby are very strong in many places. But that said, going forward, here in Hitachi and in my past role as an international consultant for IBM Corporation, I have been going all around the world, and I can clearly see in the eyes of the execs of Shell and BP and some of the top-notch companies, they are really trying now, they have started trying now to move to renewable energy. Of course, there is always that wonderful question, wonderful thing that was mentioned by the scientists that Professor Sharma was talking, that it is not always the technology. It is the human being, their selfishness, their greed. You cannot contain them just like that. We have to work towards that. Okay, the key trends, the solar rules, the China effect. The solar rules, you see, even with the massive drop in installations in China, solar PV will continue to lead the market for some more time, no question. China effect, they have cut subsidies, and this is not going to do well for China. So people believe that subsidies are a good way. I don't believe that always, but then that is what Frost and Sullivan, one of the top industrial consultants, they are talking about. Power storage on the rise, no question. And there are ways people are trying to store the power. Like the way, for example, wind turbine, right? So wind turbine, people are trying to design the blades of the, not like the three blade design. They are trying to come up with simple spindles with resin. And the vibration of that spindle, which is matched with the resonance effect, the environmental vibration, they can produce more electricity than before. So without having a huge wind turbine, people are trying to come up with a much smaller space footprint and an array of such small little spindles going up on the top. So there are ways people are trying to innovate on the power generation. Similarly, on power storage, people are thinking of many, many different ways. There is a company in UK which is taking huge blocks of, large, big granite blocks up and after, as a storage mechanism. And it is the potential energy, kinetic energy transformation. When you need to release energy, they are just letting the big block drop. And they believe that that's a fantastic storage of power. So people are inventing and innovating at the same time with many different ideas. And lastly, this offshore wind expansion. We in Japan, in Hitachi, we are working very closely with multiple companies today in Japan for the offshore platforms in the sea. How can you go and put it out in the sea, harness more wind energy and power the installations on the land? Very important. What are we doing? We here in Bangalore, our team is working on multiple smart city projects. Artificial intelligence. So this is one of the places in East Asia. There is a city. This is the picture. If you see here, that's the whole campus. That's the building. That's one building, and that's one floor of the building. How do you go using artificial intelligence, computer vision, understand that there is nobody on the floor now, off, 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 all the switches you off, AC off. When the people start crowding, how do you get automatically the ACs, fired up, powered up, right? That kind of thing. So the blinds, as the evening sun goes down, automatically the blind is drawn off. In the morning, the blinds are opened up for letting more heat come during the winter times. So a lot of smart energy buildings powered by artificial intelligence and sensors are being used today. Then comes the battery. The battery is a very interesting thing. You have got to go and monitor the health of the battery in a big way at every moment of time. You have got to go and look at using the sensors, the temperature, because if the battery is not properly cooled, the health of the battery expected life cycle goes down. And then comes the wind energy. With wind, it's a very interesting thing. With wind today, based on the different kind of the yaw, the pitch, the way the blades are positioned, every moment, every time, you can get the data out of a wind turbine, and accordingly you can condition the health of the turbine operation. This is a fantastic, I'll tell you, almost 35% increase we get out of just one thing. The dust. We are looking at some wind turbines in Gujarat, of the coast of Gujarat and in southern India, near the gap, near the Palghat gap, a little bit down actually. So what we see is something very interesting. The dust that are depositing on the blades of the wind, if you can go and just keep it clean, right time, right maintenance, 35% increase in the power output. And we get to know all these things using basically data analysis, right? My last section of today's of last 5 minutes, it would be on circular economy. One important thing we talked about is decarbonization, carbon emission reduction. But then there is also another thing. So that was about renewable. Then there is a non-renewable world, a finite source of raw material, tungsten, manganese, thorium, as somebody was talking about, right? How do you go and take care of them? Do you always keep, mining them from the earth and then using them? No. You have got to find out some ways of recycling them that will help reduce our dependence on other countries, improve our own resilience, and our self-dependence, that Atmanirbharata, right? So now, this is a $4.5 trillion industry, 45 billion in India alone. This is such an important industry. There's a lot of supply chain uncertainty. You can see that, as I told you, in the automotive industry. We have to connect the dots, and we have to come up with a platform to do that. Now, this, you see, is for the remanufacturing. Remanufacturing is an important thing. Many high-value items, like $500,000 worth of transformers, when it's not working the way it is, how do you go and refurbish, remanufacture, redo it? Some portions you take away, the other portions you keep, and you replace, and then again you bring it back to circulation. Some of these things in Houston, Texas, an oil company, they may not be using it. But in Saudi Aramco, where the temperature is much higher, that compressor is working perfectly fine. So you have got to do reverse logistics, bring that over here, redo it, refurbish it, and it's working. And it has got a remaining useful life. And finding out that remaining useful life of any high-value manufacturing products is a very important thing today. And that can be easily done if we start taking data in deployed, decommissioned, disposal at every moment of time, just like we have the Fitbots that we wear when we walk. We have the Fitbots or the sensors wrapped around those manufacturing devices. And those devices keep giving out those vital statistics at every moment of time. And if you can go and you do the trend analysis, you put them in a neural network, it will come up with a much more deeper and accurate estimate. What is the remaining useful life? So the devices of tomorrow are going to be more and more fitted with such sensors. They are going to be connected, and if they don't come fitted, we can take our own sensors and put it on them and do this thing. And finally, when we create a circular economy platform, we have got to look at the key stakeholders, the manufacturers, like Siemens company today. If something goes wrong, they will reship the part to Germany. They don't remanufacture here. But if you remanufacture here, two things happen. A, the cost is reduced, carbon footprint is reduced, and most importantly, jobs are generated, the skills go up. It's an amazing thing. The skills go up of the local populace. It's a massive, manufacturing, remanufacturing job market, skilled labor pool market that we can tap into, and majority of the skills out here are not available. We are semi-skilled or unskilled. How do you go and get into a larger, bigger pool of skills? That's what we are looking at. Now, of course, there are the regulators, the government, and of course, there are shippers and everybody. Now, and this is the last slide that I have today, that's the data flow and opportunity. So when you have such platforms where people come, and these will be government platforms, these would be platforms where the government gives credits for doing the circularity, just like the way we have the energy trading. You see, technology is awesome, but who is using the technology? The people. For what? Majority of the time for business. People's behavior is not dependent on technology. People's behavior is conditioned by the reward and the retribution system. If I get 10 rupees there, I will go there. If I know that the moment I go here, I will lose 100 rupees, I will start avoiding going there. So the human behavior can be conditioned through such credit systems, through such intelligent observation. Because you see, if you come up with a carbon credit system where there is more demand, no supply, it is not going to work, because the carbon credit price will go so much high up that you have got to go and bring it down or do some intervention, right? So you have to have a supply-demand balance. The basic thing of economics. Economics is nothing but behavioral science, right? I am not an economist, but I know one thing. If you want to go and make any one of this circularity, decarbonization successful, you have got to come up with some kind of an incentive, some kind of a punishment, some kind of a human behavior conditioning system. And the moment you have that, people will now start behaving in a certain way to cooperate with the environment better. Ideally, not always. You have to still keep monitoring them. That's why the sensors are important. That's why the human probes are important. The policies are important, the regulations are important, the government is important, and all of us important. Okay, with that, I'm done. Thank you very much. I am here for any question from any one of you, please. Yes, please. Dr. Benisha. You can use this.
Regarding your previous slide, in fact, you made a statement saying that from India, because we don't have enough skills for circular economy, we are sending the material, we have to send the material outside the country for recycling and then bring it back. I actually differ and also agree in because there are two different reasons for it. First, I agree because in terms of the precious metal recovery and recycling in India, we do have the know-how and the skills, but then the efficiencies are not high. Especially because from the electronic waste, what I'm talking about. And for that, we have to send it either to Belgium or we have to send it to Japan. And in the world, these are the only two places where it is available. Whereas for all the other waste management, I mean, for all the other recycling, India is the best. And there is another reason for it, because our informal recyclers are the best in dismantling. Of course, there are certain problems with that also, but if that is formalized and if we are looking at the environmental aspects, the skill sets are very high here, because, and this is not possible in Europe and US, because there is lack of human labor and also the skilled labor there. And for such items, segregation, sorting, with human interference is the most important thing, because until today, no machinery has been made which can replace humans for that kind of sorting which is needed. So this, I think, has to be, because, and we don't have the numbers to talk about, but we don't have even one single waste which is valuable, which goes to the landfill in our country. And this is true also for all the other Southeast Asian countries. So that way we are the best, but we don't have the numbers to show.
Can I respond to that, please? Yeah. Dr. Benisha, thank you very much. And by the way, thank you very much for letting me know a very important fact yesterday, that in India we do not end up most of the time in landfills with all these things. This is a fantastic eye-opener for me. But look, I'll tell you something. First of all, whatever I was presenting, and you are right, majority of the stuff is from remanufacturing high value industrial product standpoint, because that's what we Hitachi do. Now, when it comes to human intervention, even in high remanufacturing, you have to understand, first of all, physics, chemistry, the basic things very well, which India thankfully has. We have a lot of people who understand very good science and technology. B, we must have all those plants and machinery where we can do that. Those setups are usually not set up by the OEMs, and the top OEMs are not Indian OEMs. Majority of them, they are German, Japanese, or American. More and more, so Mahindra and Tatas, they do a fantastic job with remanufacturing, given whatever resources they have today, right? So that is the second thing. And the third thing, you are right, human intervention. We have a lot of humans in this country, but that said, we have got to free up humans more and more to do something innovative and skill them up along with the robots, more engineering. So just one thing, I come from West Bengal, right? When I grew up, it was Jyoti Babu's time. There was a lot of very, very ideological communist feelings. I have got nothing against or for them. I am a pretty apolitical guy. But, I have heard that argument so many times that the computers will take your jobs away. Computers do not always take your jobs away. They sometimes help create jobs. That's a fantastic revelation of the last 50 years. Maybe next 50 years it would be a little bit different. Maybe ChatGPT will going to go and replace all the legal lawyers and doctors, but it's a very far stretch. So probably technology is something that we should embrace more. We should think about the human capital, but at the same time, we have got to go and elevate their capability so that they can do more creative work, something different, and take the technology again to another level. So it is not like just because we have a lot of humans, don't do technology, just do. So this is my view of it. Yes. And you are right. There is no other technology very often available, and that's why we are relying on humans.
Thank you so much. Thank you so much, Dr. Kingshuk Banerjee, for a very insightful talk. Now,
No, I just asked to say that I don't have any question. I think your presentation was so good. We got everything there. If at all, there was one little doubt I had about the tax on emission. Of course, there has to be a penalty on emissions, but whether this penalty is like uniform across the globe, does it depend on the purpose of emission? Does it depend on which society that the penalty is on? So those are, I think, the questions that would need some little bit of probing.
Thank you very much, and it's a very fair question because the taxes today are pretty much blind to the needs of development in each society. They tend to go and somehow favor the more developed countries, and this is well known. But you have to start somewhere, and probably this is a start that we are doing. But thank you very much. Thanks for bringing it up. All right.
Thank you so much, Dr. Kingshuk Banerjee. I would request Professor Anirudh Chakrabarty, Dean of Academics, to honor Dr. Kingshuk with a memento. Now moving forward, next we would like to welcome to stage our esteemed guest, Mr. Arpit Sharma, Chief Operating Officer of Skill Council for Green Jobs. Mr. Arpit Sharma completed his bachelor's and master's in management program in advanced strategic management from IIM Kozhikode. He has a professional work experience spanning 20 years and relates with the organizations like HSBC Bank, Deutsche Bank, Development Bank of Singapore, and he has also finally convened to green energy space. Mr. Arpit Sharma has been a founding member of Skill Council for Green Jobs. He is also certified master trainer from GIZ Germany in the solar PV port technology and also mentors to various organizations in clean energy space. Under his leadership, Skill Council for Green Job participated at the World Skill 2022 in Kyoto, Japan in renewable energy domain. He has also signed an MOU with World Bank, We Power, during his conference in Bangkok, Thailand. During the visit, Chancellor of Germany to India, he signed the MOU with German Solar Association, BASW, Solar, for the hand-in-hand international exchange program for Indian solar technicians and subsequently participated in the Berlin Energy Dialogue 2023. Let's give a warm welcome to our esteemed guest with a big round of applause.
Forward or back? So before we start, good afternoon, Director Iit Mandi. A very good afternoon to all the beautiful, amazing faculties, students, college students and school students out here. I'd really like to thank you for inviting me from Skill Council for Green Jobs here to Iit Mandi and deliver a session on what is the scope and future of green businesses in India. So before we start, on a lighter note, I would like to put some thrust on your mind, especially to the students. So we have more students here and less of faculties. So I'll modulate my session in such a way that it is for the students. So I proclaim, I say that today I am the most important person here. Can anyone say why? Any student. Only a student has to answer. I'm the most important person here in this forum. Any student? Guys are IITians. Any student who can answer this? Why am I asking this? Why am I the most important person here on this forum? No. Anyone else? Anyone? Anyone of you who wants to give a try? Yeah? Please? Yeah, please speak. Anyone? No. Okay, I'll tell you I'm the most important person here because I'm the only person who is standing between you and your lunch. And I'm the last speaker. Okay. Okay, it has changed. So I take my words back. I'm not the most important person. Okay. Okay. So I would still request you to listen to my session a bit carefully because it is about employment, it is about skills ecosystem, it is about what India is doing, what India aims to do, and what is the future of jobs. which is highly relevant to all of us, whether we are in academics, whether we are in industry, anywhere. So ultimately, your education, that's what we believe as industry people, everything should translate into results, and result is either employment or self-employment, right? So I'll try to cover. Okay, so Skill Council for Green Jobs, as you can see that it was created in 2015. It was registered as a society, and it was created by Ministry of Skill Development and Entrepreneurship and Ministry of New and Renewable Energy. It was also promoted by CII, which is the Confederation of Indian Industries, and that's how this organization was created. It was created as a result of COP21, which is also known as the Paris Agreement, where India had given some really important targets in an international forum of installation of, which is one of the most important targets during COP21 was 175 gigawatts of renewable energy to be installed by 2022. And that's when the ministry felt the need of creating a sector skill council in order to create skilled manpower across the country, especially in solar. Then we see that we are the only body in green businesses which has been given a awarding body status by National Council for Vocational Education and Training. So we have the ministry, we have the NCVET, and then we have the Sector Skill Council for Green Jobs. These are the sectors which are covered. We have renewable energy, environment, forest and climate change, sustainable development. So solar PV, solar thermal, ma'am, so we are covering your favorite sector, solar thermal. And we'll also share with you what all good work we have done along directly and indirectly with Deepak Gadia ji. So we have solar PV, solar thermal, wind energy, small hydro, storage, clean cook stoves, biofuels. Then we have solid waste management, which is the municipal agricultural waste. We have water management, sewage treatment, rainwater, e-waste, carbon sinks, green constructions, green transportations, green hydrogen, energy storage. So if you just pause it for a few seconds and think about all these areas, they are actually the areas which the previous speakers have talked about. We talk about green hydrogen, then we have an important component of desalination. We have a component of wastewater treatment, for example. We have a component of renewable energy that needs to be installed. So this water molecule has to be broken down through, the electrolysis has to be done through green renewable energy sources. That's how it would be green hydrogen. So if you see all these components, whether it is waste management, solar PV, wind energy, green transportation, electric vehicles, every component is that we cover. Honorable Modi, when we go to COP26, Honorable Modi, Honorable PM Modi, he announced a very highly ambitious target on during COP26, and he gave a very important speech on the 15th of August 2021. Our Honorable Prime Minister said that we have to make India energy independent before 100 years of completion, which is 2047, and we are also emphasizing on the mission circular economy. During COP26, we as a country, we said that we will have we set up a target of 400 gigawatts of renewable energy installed capacity and 500 gigawatts of non-fossil fuels. We also announced the National Hydrogen Mission. We said that India is going to be net zero by 2070 and we would reduce our carbon emissions by 1 billion tons by 2030. And I don't know how many of you can understand the gravity of, except a few, I don't even expect the students to understand the gravity of net 1 billion tons of carbon reductions, carbon emission reductions, but it is something humongous. And the industry can understand that because your emissions are directly linked to development of a society, development of a country. And when you say that you're going to reduce the emissions, it impacts the society as a whole, the development as a whole. So now as a developing country, you have to pollute less and develop more, and that can only be done through technology transfer and finances. So we have our honorable PM also said that we have launched a campaign on water conservation. We'll have plastic-free India, and we are in a process of completely stopping the single-use plastic, and we have to take the Swachh Bharat mission to a next level. That's why we have these municipal corporations, Swachhta Sarvekshans, and for example, I am trying to talk to you in a little layman terms, so please excuse me, because I'm trying to come to a level of a student and not talking to an industry. So we have Swachhta Sarvekshan of every municipality in the country. Like Indore stands first, number 1. So there is a competition between various municipalities in the country. So India has taken this initiative to a very, very next level, and Skill Council for Green Jobs has enabled more than 5 lakh certifications of sanitation workers. So this is the India's pathway to combat climate change. At Glasgow Summit, when I say COP26, it happened in Glasgow, Scotland. So we said that we will raise our non-fossil fuel capacity to 500 gigawatts. We will meet our 50% energy demands from renewable sources, and we will cut our carbon emissions to 1 billion tons. So these are the Panchamrits on the right-hand side, you can see. So what are green jobs? Green jobs, ILO defines that green jobs are those jobs which contribute and preserve and restore the environment by improving the energy efficiency and raw materials efficiency, and they are limiting greenhouse gas emissions. So you see everywhere in this world, everyone is talking about low emissions, greenhouse gas accounting, carbon trading, renewable energy, solar installation, wind installation, solar wind hybrid installation, green construction, green transportation, green hydrogen. The whole world is talking green. And that's where, in the midst of that, the opportunity lies for all of us, not just as the industry, not just as educators, but as potential employees or employers also, for that matter. So this is a little older slide. I did not want to take a chance of having incorrect data, but as in 2022, wind power, solar power, small hydro and biopower, these are the installed capacities of the country, which serves as a basis of how will we grow by 2030 and what is going to be our strategy in terms of installation, commissioning and employment by 2047, which is 100 years of India's independence. So this is the energy sector, current, then we have 2030, and then we have 2047. So even in these charts, you can see that India is getting greener. These charts are getting greener. So we'll have a total installed capacity of, we are projecting RE installed capacity of 1,125 gigawatts, and the total would be 1,325 gigawatts. This is how the renewable energy share is getting increased from current scenario to 2030 62%, and 2047 we are going at 85%. So 85% of our energy would be through renewable energy sources, and that is a very, very ambitious target. Okay, so these are the projections by 2047. We have renewable energy installed capacity of 1,125. These are India is going to increase our manufacturing capacity to multifolds. That serves a lot of things. It serves net zero. It is a huge target of increasing our domestic economy, lesser exports, more jobs. So a lot of things. And we are also anticipating an investment of around 50 to 60 lakh crores in this particular sector. And almost all top corporations in the world today have their eyes on India. So we have gentlemen from Hitachi. Hitachi is a huge, huge organization, and so organizations like Renewable, Sun Edison, they all have their eyes on India because it is one of the biggest markets in the world today. So Our main mandate as an organization, like you study in your respective institutions, so what we do is we do a skill gap study first. Then we identify various curriculums, what are the courses. Then these courses, I will share a complete life cycle of that. Before that, okay, I'll just take your eye on this. These are the skill gap studies that we have done. In 2016 and 18, we did a skill gap study on solar PV, solar thermal, wind energy, and this was through Ernst & Young, EY. This study was revised in 2018. Through KPMG, we did a study in 2017 in solid waste management, clean cooking, green construction, water management. And recently, in 2023, we have done a study with supported by JP Morgan Chase on the landscape of green jobs in India. And these are the new skill gap studies that we propose to undertake. And they would be on hydrogen economy, battery storage, circular economy, and pollution. You can see these are the studies, they are on our website. Any researcher, any student, any faculty, if they would like to go through them, they would find it very, very nice. So these are the insights from a recent study of Skill Council for Green Jobs, and this talks about a lot about employment. And this should really interest every student, every researcher out here. So we are estimating that we'll be creating around 3.5 million jobs, India as a country, by achieving a target of 280 gigawatts of solar and 140 gigawatts of wind power. So existing workforce, we have 1 million workforce, and we aim to employ 1 million more workforce in this particular sector. So these are the sectors. You can see the share is the maximum jobs would be certainly in rooftop solar. You can see that by 2030 we'd be creating around 43,000 jobs. And utility scale, the big megawatt scale plants, they will create around 38% of jobs, and 23% of the jobs would be in the wind sector. This is the, if I go on a breakup, year-wise breakup, no, not the sector-wise breakup, then we see that this is the existing workforce in renewable energy space. As on March 2023, this is the workforce that would be created by 2030, and this is the difference between by 2030 and 2023 and 30. This is the number of manpower that would be added. So we see around 3,94,000 people that would be that are there in the industry today, and around 1,44,000 people would be added between 23 and 30 in the total RE space. So this gives us a platform of a huge employment, huge employment in all these sectors, and not just renewable energy alone. So areas like waste management and green hydrogen and clean cook stoves or green transportation, they are going to boom like anything. So this is what the Sector Skill Council does. As Green Job Sector Skill Council, we do a skill gap study, then we do an occupational mapping, we identify what is the job role in that particular sector, then these national occupational standards are created, they are assigned a NSQF level. Like for example, a person who does a solar installation, he is level 4, and an individual who does a solar designing is a level 5. A person who does a solar, who finances a solar, who learns how to finance a solar proposal is a level 6. So similarly, NSQF levels are assigned to various job roles, and subsequently the courseware, the teacher courseware, the student courseware is being developed in-house and with the help of some industries, and then we seek approvals from NCVT. This becomes a national qualification, and after the qualification is approved, we affiliate suitable training partners across the country. We do not do the training ourselves. We have around 550 training institutions pan-India. They do the trainings. The program is being rolled out. We train their faculties, which is the training of trainers, TOT, and then the assessment and certification is carried out. And finally, the jobs, the people, we ensure that all these trainings are done as per the standards of the industry, and these candidates, they become employable. And with pride, we can say that the courses that are being run in these educational institutions, more than 70% of the people, they are being able to attain good jobs in the green space. So one of the strategies that we followed is, suppose we talk about trainings in solar. So we identified that, a person, a candidate who is trained in Ladakh or J&K, he would not want to migrate to Rajasthan. And let's assume that there are very less plants, they are coming up in the state of J&K. So we would shift our focus completely to that state where the plants are coming. So what we do is, we identify, for example, the Rajasthan state. We say, okay, fine, this is the Bhadla power plant, which is the biggest solar park in the world. We set up a training center. We ask our people to set up a training center near the plant, take up the local manpower, train them, certify them, get them absorbed in the industry. So a lot of things are saved. Migration is saved, people's interest is saved, local employment is generated, the state's GDP increases for that matter. So a lot of things, so we kind of devised this strategy, and with this we have done over 5.26 lakhs of trainings. We have trained, during COVID, we also launched an e-learning management system, which is SEMS, SCGJ's e-learning management system, and we were able to train and certify around 2,043 candidates, and this is how the journey has been. So if you see the growth, the renewable energy has been very consistent, and now we are kind of forecasting that this graph is going to pick up very, very soon, and it's going to rise very sharply. And the waste management, we have picked up very well year on year, and this is the grand total. These are some of the job roles that we have created, and they are all national occupational standards approved by Government of India, and these are national qualifications. So we have, for example, a solar PV installer, electrical, a lighting technician. See, when we develop all these job roles, we do not only consider the industry part of it. We not only consider the urban areas. We have to also think about the rural areas. So for example, a job role of a lighting technician is very much relevant in a rural area, in a tribal area. I would like to give you an example. I happened to, as SCGJ, we happened to attend a stakeholder meeting of transgenders. And we see them, we see all these transgenders, begging on the streets. So we developed a project proposal where we said that, instead of begging, now you please learn how to make a solar home lighting system, sell it on the streets, do the operation maintenance, go in rural areas. So there are a lot of capacity building programs, and all these initiatives are designed keeping in mind the entire interest of the society, community, and the industry. These are some of the estimated installed capacities. We see that Himachal has current capacity of 7,500 megawatts, and this is going to increase to 17,500, and additional capacity of 10,000 megawatts would be added. And this gives an opportunity for a huge employment in solar only. This is only solar PV. So we are also closely working with International Solar Alliance, where a lot of candidates from various African and Latin American countries were trained. We were these trainings were done the candidates were from 82 ISA member countries, primarily African, and our master trainers, they delivered these sessions. And we are soon going to take up this project again for these online solar water pumping trainings. These are the countries. If you can see, we have Maldives, Sri Lanka, Mauritius. A lot of nominations came from Ethiopia, and this program was a huge success. It was only a 5-day program, but it went very popular. This is when we signed an MOU recently during the presence of the German Chancellor, and I happened to sign an MOU during his visit, and we also understand that there's a lot of requirement in Germany for for technicians, for manpower. So we intend to create some very, very good technicians out here in the country, send them to Germany for 2 years. They work there with German companies, and eventually if they perform well, then they get absorbed in Germany. So I also happened to, just after this MOU, I had gone to Germany during the Berlin Energy Week, where I had personal interactions with the Secretariat, as well as the German companies, solar companies, which includes giants like SMA, which is #1 in the batteries. And they are very keen on uptaking Indian manpower. So we are in the process of designing this international standard curriculum for them. And this process of hand-in-hand migration has already started. So other major activities, we can see that we have GIZ, which is a German organization. We have upskilled more than close to 2,000 certified Surya Mitras. Surya Mitras are individuals who can do solar installations, they can do the electrical work, civil work, and they also know a little bit of entrepreneurship. So it's a very popular title given by Ministry of New and Renewable Energy. So we have upskilled close to 2,000 Surya Mitras. We have also trained around 1,500 solar State Bank of India bankers under Suprabha World Bank program. And GIZ has also supported. GIZ is a very close partner of Skill Council for Green Jobs, and they support us in many, many activities. And recently, we have developed an e-learning platform for technicians for wastewater. And you can see that 80 solar rooftop entrepreneurs, they were being created by SCGJ in 22-23. These are the specialized training programs that we do. I remember Vestas, which is the biggest wind turbine manufacturing company in the world. They had come to India. They set up a blade manufacturing unit in Gujarat. And when I was talking to their, we had a very, very detailed meeting with their MD and CEO. And they were in huge demand of manpower. So that's when we upskilled our solar technicians of Gujarat, got them jobs in wind energy, and now we have close to 300 people, technicians, Indian technicians working for a giant like Vestas. So that gives us an immense pleasure to be able to do this kind of an impactful work. We have also done greening of NOSes, so whatever curriculum educational institutions follow, we have created greening of NOSes for them. NOSes is National Occupation Standards. So these are the e-learning modules that we launched, SCGJ's newsletters, and a very important thing for students. So how do we go back? Yeah. So there is a world skills competition which happens every 2 years. In 2022, it happened in Kyoto, Japan, and renewable energy was first time added into this competition. So 1,000 candidates, they got registered in the year 2022. And by October, we were able to freeze down to one single candidate. We trained them for 6 months on international benchmarks, and then he was taken to Kyoto, Japan. He competed with countries like China, Japan, and some other nations, and he was able to outperform there. So today, what I want to tell you is that India as country, our training programs are being replicated or appreciated by countries like Germany, by countries like Japan. So this is the kind of strength that we have developed. So these are some, in water technology, we won a gold medal in Kazan, Russia. And our candidate was highly appreciated and felicitated. In fact, the top winners, 5 winners of renewable energy, they were all felicitated by their respective chief ministers of the state. So these are some of the snapshots of India skills. These are the trainings which happened. This is the training when this happened in India, and after this India skills competition, this candidate is supposed to go to that particular country and perform. So these are the pictures of renewable energy competition which was held in Kyoto. And our candidate is doing the solar, wind installation, hybrid installation. You can see a tilted roof. You can see ACDB installations. And he also outperformed on a Nessel, a simulation, which is a wind turbine simulation. And that is something he learned there only, to our surprise. So his name is Shivam. He's from Madhya Pradesh. And even he was felicitated in India and abroad. And he brought laurels to us. These are Azadi Ka Amrit Mahotsav sessions that we do on weekly basis, where we invite an industry expert. He talks on various subjects in green businesses. So we have a very diversified session. Last week only we had Mr. Dinesh Babu, who was in USAID and then in EY, and now he's going to Singapore, and he took a very, very detailed session on carbon markets and gave his overview. So we also planned to invite Mr. Deepak Gadia ji. Unfortunately, he was traveling at that point in time. So I got connected to him a few years back. So this might interest you. These are the artificial intelligence applications in renewable energy. You can, without taking much of your time, you can just go through it. And these are the key sectors, as I mentioned. These are the opportunities, forthcoming opportunities in the energy space. We intend to, as a country, we intend to make India as the energy capital of the world. We intend to be the green hydrogen exporter of the world. And we are highly focusing on the mission circular economy. And these are the initiatives. And these are the goals 2030 and 47, just like we as a country, any national body today talks about two milestones, 2030 and 2047. 47 because it would be 100 years of India's independence. And you can see that this is what we are estimating, that around 3 to 3.5 crore additional jobs would be created, and over 1 crore skill trainings would happen, and job felicitations would happen. This is the future outlook. We are giving a lot of thrust on entrepreneurship development, because we can see in RE space, especially in solar, we see a lot of micro entrepreneurs mushrooming in the country, and mushrooming in a good way. And this gives them quite a stable financial life, and it also serves their passion to be working independently. So we have these huge companies who are working in the area of renewable energy, and you have their contractors, subcontractors, dealers, distributors. So we have place for everyone as a country. So this was all about the green job space, the skilling sector, the future outlook, and I'd be very happy to answer any questions, if any. Thank you so much. Yeah. Ma'am, I'm scared of your question, so I'll be little...
It's good for you.
Sure.
If you're scared of me.
Right.
I'm very impressed with your presentation, and it sounds like great. I am just asking few questions. Number one is about the largest number of sort of ground level workers. What kind of sustainability of their jobs is? Do you provide jobs, or you pass them on to some companies? And like I am saying this from my example, I witnessed in Indore the Safai Karamcharis.
Yeah.
And the status of Safai Karamcharis, the kind of उनके साथ मतलब इतना injustice होता है
जी.
उनको पूरी मतलब उनको कॉन्ट्रैक्ट पे ही रखा हुआ है, 4,000 रुपए में महीने में सारा दिन सुबह से रात तक पोल्यूशन में वो लोग काम करते हैं
जी.
तो उनकी लाइफ के लिए उनको ही पक्का ही नहीं करते, मैं हर मीटिंग में जाती हूँ, वो सारे मेरे पास आते हैं कि दीदी कुछ बोलो आप हमारे लिए. सो एंड आई लिव अनफॉर्चुनेटली 3 किलोमीटर अवे फ्रॉम द ट्रेंचिंग ग्राउंड, जो कि दुनिया की सबसे हाईली पोल्यूटेड वो कचरे को जो डंप करके रखा है ना. तो वहाँ पर जो सफाई कर्मी हैं, उनकी हेल्थ, उनकी बीमारी, उनका मतलब ग्रीन जॉब्स में उनकी ग्रीन जॉब्स कैसे हैं, एक बात. दूसरा, आपने क्लीन स्टोव्स की बात की है, आपने कुकर्स नहीं दिखाए, आपने कोई भी सोलर थर्मल की टेक्नोलॉजीज़ नहीं दिखाई. और ये स्टोव्स, कुक स्टोव्स तो मैं बहुत सालों से पढ़ रही हूँ, पर अभी हम उसी बात में से तो निकलना चाहते हैं. तो औरतों को जो कुकिंग इन स्मोकी किचन इज वायलेंस अगेंस्ट विमेन, तो आप उसके लिए क्या कर रहे हैं. तीसरी बात ये पूछ रही हूँ कि आपका सोलर थर्मल का जो फिगर है 14,000 कुछ और 30 तक वो 22,000 कुछ होगा. तो आई वॉन्ट टू गिव यू अ पुश. थैंक यू.
Sure. So ma'am, to answer to your questions and very very transparently, पहला सवाल आपका जो है about सफाई कर्मचारीज. So we understand manual scavenging act इस देश में बना, which prevents people from going inside the sewers, and it is a punishable offence. हमने manual scavenging act पे cleaning of sewers and septic tanks के ऊपर बहुत सारे ट्रेनिंग मटेरियल भी बनाए. करीबन 4 लाख सैनिटेशन वर्कर्स को इंडिया में डिफरेंट म्यूनिसिपैलिटी के भी ट्रेंड, सर्टिफाइड देम, बट अनफॉर्चुनेटली वो फिर उस कॉन्ट्रैक्टर के ही हाथ में रह जाते हैं. जहाँ पे ऐसा बहुत केसेस में हुआ, एंड इट इज़ ट्रू, फॉर एग्जांपल इन म्यूनिसिपल कॉर्पोरेशंस लाइक पुणे और ग्रेटर मुंबई और even Indore, there were sanitation workers that who after the training and our certificate, which is a Government of India Ministry certificate, उनमें से कुछ 2 या 3% लोग परमानेंट भी हो गए. कॉन्ट्रैक्टर के पेरोल से वो म्यूनिसिपैलिटी के पेरोल्स पे आ गए. बट दिस परसेंटेज इज वेरी लेस, ओनली 2. लाइफ बिल्कुल मिजरेबल है. इसमें मैम मिनिस्ट्री ऑफ सोशल जस्टिस बहुत एक्टिवली अभी काम कर रही है, एंड मिनिस्ट्री ऑफ सोशल जस्टिस थ्रू NSKF मैम वो तो देखिए डिस्पैरिटी है ही इस कंट्री की, बट मैं ये बताना चाहूँगा. ओके चल, कुक स्टोव्स. सो हमने इन ईयर 2017 वी वर अवॉर्डेड अ प्रोजेक्ट बाय फॉर्मर ऑनरेबल प्रेसिडेंट ऑफ इंडिया मिस्टर प्रणब मुखर्जी, और उनकी जो 15 विलेजेस जो अडॉप्ट उन्होंने की हुई थी, वी वेंट देयर, वी डिड अ सर्वे, and we found out that the life of women is during their kitchen times, it is miserable. तो मैम एक इम्पैक्ट अगर आपको क्रिएट करना है सोसाइटी में, आप तो मेरे ख्याल से शायद सोसाइटी के साथ बहुत क्लोजली काम करते ही हैं, यू जस्ट कैन नॉट मेक अ डिफरेंस ओवरनाइट. सो हमने वहाँ पे अपने कॉस्ट पे क्लीन कुक स्टोव्स डिस्ट्रीब्यूट किए, उन लेडीज़ को सोलर टेक्नीशियंस बनाने में हेल्प करी. वहाँ पे सोलर प्लांट्स 3-3 किलोवाट के प्लांट्स हमने इंस्टॉल किए. हाँ, सोलर कुकर्स पे मैम हमने अनफॉर्चुनेटली, हमें अभी तक इंडस्ट्री डिमांड, हाँ, सोलर थर्मल में मैम हमने बहुत ज़्यादा अभी काम नहीं किया है, बिकॉज इंडस्ट्री का अभी बिल्कुल वी विल श्योरली, आई वुड बी ग्रेटफुल इफ यू कैन कनेक्ट अस विद सम रेलिवेंट इंडस्ट्री इन दैट एरिया, एंड वी वुड बी मोर देन हैप्पी टू. ओके, ठीक है, बिल्कुल प्लीज. जी,
में बनाए हैं या अंग्रेजी में हैं?
अंग्रेजी में भी हैं, हिंदी में भी हैं, लोकल लैंग्वेजेस में भी हैं, तमिल में भी है, गुजराती में भी है, और गुजरात में हमने सेवा के साथ बहुत अच्छा काम किया है, विच इज़ द सेल्फ एम्प्लॉयड विमेंस एसोसिएशन. वी हैव डन अ ग्रेट वर्क विद फॉर द सॉल्ट पैन वर्कर्स. एनीवन एल्स? चलिए, thank you so much. Before anyone asks me, so I think I should better make a run. And thank you so very much, Iit Mandi, for.
Thank you, Mr. Arpit Sharma, for the insightful talk. I would like to request Shri Somjit Amrit CEO iHub, to honor Mr. Amrit Sharma with a moment.
Take it off.
It is with great pleasure and honor that we welcome to the stage our esteemed guest, Dr. Binisha, Advisor, Science and Technology Cluster, Office of the Principal Scientific Advisor, Government of India. Dr. Binisha is an environmental scientist with 23 years broadband experience in the field of environmental management. She has been a field scientist, conceptualizing and piloting several environmental projects and then successfully monitoring its replications. Dr. Binisha has undertaken study visits to more than 35 countries in Europe, Australia, and Asia. She is the board member of Technology Development Board, Ministry of Science and Technology, Government of India since November 2018, and chairperson of the DRC of TBD of the same board. She is a member of AICTE, Ministry of HRD, Green Campus Committee. She is also the panel member of PBD Convention 2019 on Waste Management, Ministry of External Affairs, Government of India. Let's warmly welcome our esteemed guest on stage with a big round of applause.
Good afternoon, everybody. I think, I don't know whether I'm the most important or the one whom you want to get rid of fast so that you can go for lunch. Anyway, I'll make it as short as possible. I wouldn't give you too many numbers, but what I would want to give you is just an understanding as to what this project is, because this is something which is more relevant to the education institution. So it's on the green campus. First of all, I would like to bring to your notice about this new draft rules which was released on 26 June, just this week, which is going to be a landmark rules for the country because it talks about green credit scheme. So we heard speakers earlier talking about taxes and all that, but this is something which is something more appealing to every individual person, because tax is usually a very wrong connotation or something which nobody really wants to hear. But when you talk about green credit, so this is a kind of a very welcome program or the welcome scheme which has been introduced by our country. It's in the draft stage. Not much of details are also given. It is in the development stage. So more and more information and opinions are being sought by the government. So it actually touches every single person, and it's in line with the life mission which has been introduced by our Prime Minister, and also it is in line with several other programs on environment by the government and the climate change. So it's a very global international kind of an appeal which this particular rules have. So I just wanted to, and this although it has been introduced now, why I brought this here in this presentation is we have been doing all what has been introduced here from 2017 itself for the campus. So we have this project called the Green Campus Initiative, which was launched in 2017 with AICTE, which is the agency which accredits all the professional colleges in the country. So there are about 10,700 odd institutions which is mostly engineering colleges. We have MBAs, architecture and other allied engineering colleges also. Yeah, so here the main objective of this, it's being implemented by the organization which I represent, that's International Institute of Waste Management. It is a joint program of AICTE and IIWM, and one of the main objective is to achieve zero net carbon, that's the climate change component, and the circular economy, because waste management is one of the major component here. So here it is not just certification, it is a complete hand-holding right from the campus planning, design, development of structured implementation, and then finally measurement of it. So it's like an open book exam is how I call it. It is not something where you just have somebody coming, checking if you have done it right and then giving you marks for it, but we handhold, we see to it that you succeed. So we keep giving tips to you so that you improve. So that's about the whole program, unlike other certification programs. And it is in line with the GOOPS program of the UNEP. Why have bought this in the energy side of it? Because this has one of the major component of energy. I will not talk about the other aspects, that is waste, water, then greenery, resource efficiency and other aspects, but I will give you examples of the energy efficiency part of it. There are several steps to it, starting from the registration of the institution. So the institution has to register, and then there are ratings and other schemes. These are mainly it is something which these steps what have been given. It is mostly on voluntary basis. First of all, a benchmark is established. We first spent about 3 years just to establish the benchmarks and also to develop guidelines. And today AICT and NAC uses these guidelines for the country for doing the certification and also for accreditation. So if any institution has to get the approval of NAC, then they have to follow. So there are about 140 credits which has also been given in under this scheme. So we have divided this in different pathways. So there is this eco-infrastructure, lifestyle changes and outreach. So it's not just about the campus, but we also give points based on how much an institution adopts a village or a surrounding ward or a community in that area. So, final platinum grade is given only when the institution actually goes beyond their campus. So that's why I call it as a holistic program. Now let me come to the benefits of it. It is not like the other systems. Here very clearly a campus actually sees cost savings. So I put the example of energy because today we're talking about energy. So energy through resource efficiency, when it was done in Tamil Nadu, one of the campuses was saving about 30,000 rupees a month only from energy costs. And that too without having any kind of retrofits, without spending any money on it. So that's the kind of savings which it's not that they don't know, there are all professors sitting there, but when it comes to documentation, when it comes to proper implementation of structured plans, usually there is a lack. And that is the reason, lacks. So that's the reason we have introduced this program which will guide you through very, very simple processes. Yeah, and this way it helps in branding, not only cost savings, but also has an international appeal. This is mainly for the private institutions. Even NIFR gradings and all that, it helps. Again, I'll talk to you about 3 different case studies. This was a very interesting case study because I wanted to bring to your notice that it's not just on the energy per se, but sometimes, especially in India, this is true because every kind of audit I have come across some such cases. Here it was, the campus was showing 7 lakh units were being annually used before 2020. And because we actually look at their energy bills, that's the first requirement. And then in 2020, we found that they were using only about 5 lakh units, and which is 57.44 units per capita consumption of energy per year per unit. That's the benchmark. And in India, as per the Bureau of Energy, it is 129 units, and it's only this is like a very good benchmark which it was showing. So we looked at the past and we looked at this, and then we found that if it is during COVID time when nobody was using the campus, we had this much of electricity. So we were like wondering as to how can this happen? And they were also surprised. They said, no, this is not possible because nobody was there in the campus. And then we started looking at every single portions or the buildings. And then we noticed that there was one small waste storage unit, a small building, and that was where the maximum unit was being consumed. And there was no instruments, nothing, no appliances, nothing. And then we realized, this became very, very hot topic in the entire administration. Everybody was had come and wanted to check and find out why this was happening. Then the electrician came, he checked the electrical wires, and then he noticed that this was going underground to the next Jopatpatti, which was there behind the institution. So, it was a clear case of theft, but they wouldn't have even noticed it if this audit was not done. So, this is not just one isolated cases. Like this we have found for water. In fact, when we did for one of the big stadiums in India, on water we found not that somebody was thieving, but internally there was somebody who was doing things. So these kind of things come out and this can be plugged. And it's very important that, I'm not talking about the theft and other things, but like this there are many other things. Sometimes you will have an old appliance which is energy consuming. So these kind of things can be rectified. So that's why savings is one of the most important thing which the institutions have realized, and they come back and they do renewal of this scheme every year. And they set targets and they're very happy about it. Yeah, the next case study, I'll just give you a few numbers. For a very small college, when they installed, this is about the renewable energy. So this is installation. So for solar PV, 75% of its grid power requirement was being met, and they had a very good saving because of that. Today what they're doing is they're setting up another 75 kilowatt solar PV so that they can become net zero and also energy positive so that they can give it back to the grid. And biogas plant, just a small plant, because for small institutions, even that small saving is a big money. So 4.5 cubic meter biogas plant, 2.5 kg they could save, which means LPGs they could save. So, and then it also takes care of their food waste. It also helps in recycling. It helps, the sludge was used for their garden. So there is a lot of other benefits also which is there, not just the energy benefit. The third one on eco architecture, because solar, passive daylighting and other things, if you look at the savings, 10 to 15% of electricity saving can be done with this. So for already existing buildings also, we will give some certain tips as to how you can make it more solar passive. And just 2 instead of 5 tube lights in a quadrangle, it can actually save up to almost big kind of savings which you're getting, 178 rupees per day. And for AC, of course, is again a big saving which they can get. Lights being switched off, which is just a small measure which they adopted, and for that itself 16.8% of savings were being got. So this is for a small, I don't know, it's not moving. Yeah. This is for a small institutions. For big institutions it's much bigger, and I'm sure IIT should follow suit, and you will see the way things get organized in your institution. Yeah, these are the different categories of certification. Of course, this we don't attribute so much to it, but I'm sure it also has these. This is like a cosmetic help. Why we are talking about this? Because why India took this up? Why the government is very particular that this scheme should be introduced? Should be implemented, is because it's not about one or two institutions. All the AICT approved institutions, I'm not even talking about other colleges, just the AICT approved institutions, which are 10,000 odd institutions, it is almost coming to a state like Goa. If everybody follows all this, then almost it is like an entire state of Goa has become completely green. That too, it is just on the green ratings I'm talking about, benchmark. Whereas if everybody becomes platinum, then it is like fantastic for the country. So it should start from the colleges, because they are the ambassadors tomorrow. So it is not just one institution doing, because if we do it in such colleges, they become the managers of or decision makers in other institutions, and that they will also follow that suit. And here the entire program, it is not that a college can just give it to some consultant. That's not the way it is done. It is every student in the institution has to be part of it. So every the surveys which is being done, the student participation, unless that is there, they don't get the credits. So that is how we have built this, or we have made this program. So it is for the entire institution which will be participating in this program. There is a fee for it, which is a very, very minimal fee for this entire for renewal also there is a fee, because if something goes free, then definitely there is no value for it. So that's how we've introduced. And of course, it's only ours is a non-profit organization, and AICT has actually looked at all this, and that's how it is done. I think that's it. Thank you. And I hope you will enjoy your lunch. Thank you so much.
Thank you so much, Dr. Benisha, for a very interesting talk. Now, I would request Dr. Aditi Haldar to honor our guest, Dr. Benisha, with a memento.
I've already got it yesterday. I know.
Now, moving on to the last talk for today and for this G20 S20 conclave, we invite Dr. Ranga Bodavala, Hoshang Patel Tech Center. Our esteemed guest, Dr. Ranga, has an MBA and PhD in Information System and was a TechME Fellow in Harvard School of Public Health, Boston from 1999 to 2000 and again in 2021 to 2022. Dr. Ranga, after working with UN organizations in various African countries and India, founded an NGO and for-profit organization worked with solar energy and solar light for poor in Africa and Asia. He hails from an agricultural family and from a village in India, so he is naturally interested in technologies that make life of women and children better, safer, and more productive. He firmly believes that the modern technologies in energy generation, storage, electrical motors, water pumping, treating will dramatically change the landscape of villages. Let's warmly welcome Dr. Ranga Bodavala for the talk on New Age Solar Smart Street to save 58,000 megawatts of coal power and 60,000 crores of electricity annually in India.
Can you hear me, please?
Yes, sir, we can hear you.
Yeah, I'm sharing, my screen. This Mac takes a while. Can you see my screen? Now the PowerPoint. Can you see my PowerPoint, please? Hello?
Yes, sir, we can see the screen.
Yeah. Is it? Yeah. Is it now? Is it now full?
Yes, sir, it's in full screen mode now.
Okay. Can I start? And you're giving
Sure,
me
sir.
10 minutes, 8 minutes, whatever. Thank you. Thank you for the wonderful opportunity. When I'm sharing my screen, I see my screen only. I don't see any one of you. I hope I can also see in a small screen the entire audience. Can I start, please?
Yes, sir, sure.
Okay. I'm unable to see any of you. Only I see my full screen. Well, that is for the time being maybe okay. I've been working in solar for a while, as Madam has read the small work I've been doing. So whatever you see in this screen is a smart street light. The image looks very clean and clear. I'll explain why that's possible and all. We have been used to measure the watts and all. We think watts is the criteria of lumens. May not be, as lumens are getting improved by the LED makers on daily basis. Just my next screen. Whenever I was traveling in the villages, the first thing I hear about solar street light is people steal the battery. We can't maintain them, and you need to put water. Even the best of institutions, including IITs, never have a maintenance schedule for street lights just by putting distilled water. And again, the battery declines and battery performance cannot be measured. And even if you do all of that, the battery will last maybe 500 cycles, mean 2-3 years, 3 years maximum. That's what I know. And now you know how the new street lights are lithium iron phosphate based, and how different they are, how digital they are, how compact they are, how rugged they are for the heat of India or Africa or even a desert, how they can run even up to 6,000 cycles. So the batteries I procure are 2,000 cycles. 6,000 cycles is nearly 20 years. They work 20 years, some of them guarantee. After 20 years, if you manage them properly, they lose maybe 20%. So what you see, I just added an image now. This is a street light, not in a tribal area, in Mizoram Central University, which has 380 street lights in this shape or some other shape. So, as you know, the panel must be still working perfectly, and the pole is good galvanized quality one. What fails is battery and the electronics. So, I come back here to the subject again. So my conversation, appreciation, my work is not so much about solar, which is happening, which is great, which is my pet topic, but the LEDs, the solid state lighting we call in technical terms. When I started my work 15 years ago, I used to buy Citizen LED for 60 lumens LED for $5. Now I buy Nichia, the world's best LED, 220 lumens for 1 watt. For 5 rupees, 5 rupees 20 paise exactly, and some tax or less tax, whatever. And they always tell me, I am in touch with Nichia, Japanese company, that they have in the lab 300 lumen LED, meaning my friends are students and other government functionaries. In the next 2-3 years, you can have a LED street light good enough to illuminate a rural colony or a tribal area for 3 watt of power consumption, 3 watt, 900 lumens, directed Nichia LED with a wonderful color sensor is that's enough. So when we go back to my first slide, the light that you see now is 4 watts. You don't want to believe, but I can give all the specification statistics. This is what I make daily basis. At least daily we make 50 to 60 lights like that. So when you have this kind of brilliant, wonderful, high lumen emitting LEDs, it's becoming so easy unless you stick to the world specifications and say, I want the consumption as the criteria, not the delivery of lumens. Well, I come back here again to tell you, you see the components here, 1, 2, 3, 4, 5, 6 here. I already mentioned about the LEDs. The battery pack, I use lithium iron phosphate battery is 900 rupees, not 6,000 rupees lead acid, 5,500 rupees lead acid battery, which needs a big box and, mount and all that. These batteries are your fist size or maybe 4 times your mobile phone size, more or less, exactly 4 times your mobile, 3 times to 4 times mobile phone size. They sit well within the case, and I use a panel, and the panel prices and all that. And my other enjoyment and appreciation is microcontrollers, which are advanced. 42 pin is 55 rupees. You buy a big ST microcontroller, or all the electronics are 200 rupees. You want a Wi-Fi module in that, dollar means 80 rupees. You want a good camera, CC camera from one of the good brands, just the module, not the entire housing, electronics and all. The module is 200 rupees, in bulk, maybe 300 rupees in retail. So a smart street light with, extraordinary engineering, ability to monitor your battery, monitor with sensors, with double sensors, calibrate the light, properly charge the battery, maintain its life cycles, can cost, by paying all taxes to my Nirmala madam, is around 3,000 to 3,500 rupees. If you think of India size, it will be much less, much less. So I told you batteries, which are going to change everything we know dramatically. We always think they're going to change the electric vehicles. That's, everybody talks about, everybody jumps about, everybody has metrics to measure the EVs, two-wheelers or four-wheelers. But the revolution is in your mobile phone, which is already happening, and the next will be in, I don't call them any longer street lighting, but I put them in temples, put them in schools, hospitals, whatever. Actually, I recently been putting them in burial grounds. It's very silly. People want solar street lights in burial grounds. Always the burial ground is outside the village, which doesn't have a cable connection. Somebody doesn't go there to switch them on or switch them off. So think of India, the size of India. We are not lighted the way it should be lighted. The best colonies are heavily lighted because power is available. India, for the size that we are, 10 lakh villages, hamlets, urban, all other, even roads, I'm saying roads, parks, whatever entity you think you can light up, if it is so inexpensive. The highest cost of my light is the pole, honestly. The iron is more costlier than all the solid state electronics and the panel. So if India needs 20 crore street lights, normal way, assuming they consume 1 watt of electricity with all wastages a day, 250 crores you are going to spend if you want to light up India a day, and 365 days, just imagine. And imagine the coal power you need to produce and run it in the night, because this is happening in the night. These are the calculations I made. 50, 60,000 megawatts can go very much into lighting up India, the way India is progressing. And I have a different model, pay as you go model, which I'll explain in the last slide. I want to experiment my work in small countries. I keep doing every day, as I told Satoshi also, 30, 40 lights, 50 lights from our center. And I identified Botswana, a population of 20 lakhs. It's not a poor country. It is very rich with diamonds now. In 10 years, it became very rich. Another really poor country in West Africa, Gambia, with 30 lakhs. I got an Indian friend who is willing to sponsor maybe 30,000 lights in the country, 10 to 12 crores, right? He's doing a business of real estate, not diamonds, IT and many others. And he's willing to do it as pro bono. We signed an MOU and we are going to set up a unit there so that he can show it to all his political friends and get a mileage out of it. And the Gambia, we needed 10,000 of these smart street lights. We are raising funds from our German friends. Maybe by September we can announce. So within a year or so, we'll light up these two countries thoroughly. And whatever I'm talking is It's true. Any one of you can visit and procure one light from me, test it and see it, and of course you can log the entire data in the internet. The present batteries I use may be working 7 years, 8 years, but somebody needs, he can buy it for 6,000 cycle batteries. The electronics work and the LEDs work. Well, after 10 years, you want to upgrade LEDs, you may buy 350 lumen LEDs from the same niche for 100 rupees, the entire board, and replace, and you have much superior bright light. So the technology that we see is wonderfully available to us, unbelievably available to us. Even I'm mounting these days infrared LEDs on the side of my light. So when they are blinking very fast with a high frequency, animals get afraid and they think it's fire. So they don't enter a tribal hamlet, animals which can, harm, especially cheetahs or even elephants see the light as a fire. Not the white light, I said infrared, another cheap infrared light. All these lights can be on the cloud and they keep giving the data and you can monitor, you can do your analytics or whatever. And this is a pretty intelligent way of deploying our coding into a solid state lighting. Thank you so much for this opportunity. This is a very specific project I'm saying. I'm just saying you can light up a small country for 10 crores. In case of Gambia, 4 to 5 crores. And that's the end of the story. So, and they work, they're not going to fail. So that's my brief conversation with you. Any doubts, because you're going to lunch, based on your thing, you can ask, but you can ask Professor Saptasil. He is a wonderful friend, and he knows as much as I'm talking. Thank you. Thank you again.
Thank you so much, Dr. Ranga, for this very insightful talk. Now, I would like to invite Dr. AVM Pranay Sinha, Strategic Advisor of IIT Mandi, to felicitate our guest, Ms. Priya Yadav, Scientist C, MNRE, on stage. I would also request Dr. YJ Park, Director of India-Korea Center for Research and Innovation, to be present on stage. And I would request Sinha sir to honor our guest, Dr. YJ Park.
Come. Welcome.
Thank you so much. Now proceeding forward, I would like to invite Dr. Satvashil Pawar, Associate Dean Strick at IIT Mandi, to deliver the closing remark and vote of thanks.
Yes. So Dr. Ranga, thank you very much for the online talk, and we'll definitely looking forward to host you at IIT Mandi. So whenever we get a chance, I would request you to visit the campus, and we will have more interactions, and we will see how we can work together for this wonderful street lights.
Thank you.
Yeah. So this is what, yes. Yeah, so we already got a request that we should work on these solar street lights for the campus.
Yes.
So we are looking forward to host you at IIT Mandi then.
Thank you.
Yeah.
My pleasure. Honor. Thank you.
Yeah, thank you. Yeah. So now it seems in the end I'm the most important person because this is the vote of thanks, and which is the in between your lunch and it's between your lunch. So I would like to say a few words about vote of thanks. Honorable delegates, faculty colleagues, student friends, and ladies and gentlemen, we are now at the end of this G20 S20 event, and of course at the end of today's session. I would like to express my heartfelt appreciation to all the dignitaries in attendance. So Professor Lakshmidhar Behera, Director IIT Mandi, Professor Ashutosh Sharma, Chair S20, Professor K.K. Pant, Director IIT Roorkee, Dr. Kingshuk Banerjee, Director Hitachi India, Dr. Ranga in online mode, Founder Hushang Patel Tech Center, Dr. Binisha, who is Advisor at Science and Technology Cluster, Mr. Arpit Sharma, COO, Skill Council for Green Jobs, Ms. Priya from MNRE, Dr. YJ Park from India Korea Center for Research and Innovation. I would also like to thank our sponsors and partners, Bell and Hitachi, as well as Deputy CM Office for their generous contribution. A special thanks goes to organizing team members and the dedicated team of volunteers who work tirelessly behind the scenes to ensure the event's smooth execution. Thank you very much. Meticulous planning, coordination, and attention to detail were critical in fostering an environment for fruitful discussion and meaningful networking, which we see happening from this event. The success of G20 would not have been possible without the combined efforts of everyone. Your unwavering dedication to cooperation, sustainable development, and innovation left an enduring imprint on this event, and it will continue to inspire us for our future endeavor. Thank you very much for your valuable contributions and for participating in this memorable event. Thank you once again.
Thank you so much, Satvishil sir, for honoring our guest and proposing the vote of thanks. Now I would like to invite all the dignitaries and audience for the lunch.